Welcome, everyone. This is Michael Gibbs, and welcome to day 3 of our AWS Advanced Networking Bootcamp. Welcome back. I'm super excited to see you. If you're just joining us and this is your first day, we are on day 3 of the Go Cloud Architects free AWS Advanced Networking Bootcamp. For those of you that don't know me, my name is Michael Gibbs. I'm the organization's founder and CEO. Now, when we talk about networking makes me really, really happy. Why does networking make me feel so happy? Because the network is the foundation to everything. And I've been working in networking for as long as I can remember. In fact, to put it into context, how long I've been in networking, my CCIE number is 7417. Back when it was an actual 2-day test, that's how long I've been in networking. And I've loved every last minute of it. The network is the foundation. So we'll just keep that. So kind of want to keep everybody informed of all the things that are going on to make sure you have the absolute best experience. Because when we do training at Go Cloud Architects, it's not about getting certified, it's about getting cloud hired. And there's a big difference between getting certified and getting hired. And because our goals are getting people hired, not certified. You will get certified, but getting hired is our goals. We do a lot to help you with that. So tomorrow, 9 o'clock in the morning, we're going to have Christina Marino, the CEO of IT Excel, a fantastic recruiting firm in New York City of 20 recruiters. They are national. They place people all the time. They place my students constantly. They placed me in 2 of the 5 jobs that I've taken in my careers and have helped my students get hired for 20 years. And they're going to be here tomorrow. And they've got a lot of available open jobs. We're going to discuss interviewing to get hired, and you'll be able to ask any questions you want. So super excited to have you here. So if you're here, please hit the like button, subscribe to the channel, and let's have some fun. Tonight at 5 p.m., there's a 95+% chance we are going to do some serious lab work tonight. At 5 p.m., it'll be with Imran Takor from my team. Imran had some family challenges this week earlier, which is why we rescheduled it to tonight. And just because he had some temporary challenges, we assume he's going to be here. This morning, he said he's going to. But, when families have some things going on, at least occasionally, we want to give them room for error. So 95% chance, 5 p.m. tonight, Eastern time, 10 p.m. UK time, we are going to do a party, all kinds of VPC configuration and things. So we want to get you all there. So let's get you all cloud hired, every last one of you. Let's get you all cloud hired. So without further ado, let's start having some fun. Let's start talking of networking. And I'm super, super, super happy to see you. So if you're ready to get started, type #cloud hired in the chat box. And as soon as I see that, I know that you're here. I know that you're all awake, alert, and oriented. When I see that, we're here. So I'm looking at some names, and it's exciting to me. I can see people that are in the US. I see people that I know that are all over Europe. I see people that are close to me in Florida. I see people in the UK. I see people in India. I see some names that I know to be in Africa. How exciting is this? All kinds of people all over the world, and we are super here. All over Canada, I see people that are coming in from. I've seen some Torontos. I've seen some Ontarios. So we love it. Good day, good night, wherever you're from. Mark, super happy to see you. Ken, super happy to see you. Jeannie, wow, always great seeing you. Evo, always great seeing you. And Marla. So let's have some fun. And yes, happy Veterans Day. Let's celebrate those who have served, those who have protected our lives. Let's celebrate those who worked so hard and gave up so much for us. So let's talk about getting cloud hired. And getting cloud hired means being technically competent. And when we're talking about web applications, and we're talking about boosting web performance, and we're talking about enhancing security, what are the things we need to talk about? We need to talk about content delivery networks. Content delivery networks are how we seriously improve speed, performance. So let's go have some fun, and let's talk about content delivery Nigeria, even wonderful. IO Cloud Hired. So really, we're talking about a lot. So let's talk about Amazon Cloudfront. So first and foremost, what is Cloudfront? Amazon or Cloudfront is quite simply the Amazon branded content delivery network. So If you've ever worked with a content delivery network like Akamai's or Cloudflare's, you know what Cloudfront is. It's a content delivery network. But if not, don't worry. We're going to talk about content delivery networks, how they work, why organizations use them, the benefits they provide. Stuff's really important. So, what is a content delivery network? I'm going to give you the textbook answer, and then we're going to actually tell you what it really is. The textbook answer would tell you that a content delivery network is a geographically distributed group of servers that provide fast delivery of internet content. Seriously? This is what the industry would tell you? That's what a content delivery network? No. A content delivery network is as follows. It's a high-speed network that's got caching servers in various regions. That's it. A content delivery network is a fast private network that's got caching servers to get you access to your data faster. And I'm going to show you how they work. Let's not make it crazy. It's 90% network, 10% servers, 90% network. It's a content delivery network, not a content server network. So these are kind of one of those things. Alonzo Coleman, welcome, welcome, welcome. I'm so happy to see you here, my good friend. So let's talk a little bit more about it. So content delivery networks are used by organizations to improve speed and to reduce bandwidth costs and to reduce the load on the servers. So content delivery networks do two things. They provide a private, high-performance, high-speed network, and they provide caching, and we're going to talk a lot about caching. But realize that caching, and we'll talk about lots of types of caching, is used to reduce the read work on a server. So we could be using caching in databases to reduce the read work off of a database, or we could be using caching on a web server to make sure that the web server doesn't have to keep supplying the same pages to the same people requesting the same information. So that's why we use content delivery networks, to speed things, to promote scalability, and it really offloads the servers. And we're going to walk through that in depth, and we're going to show you, but just know it ahead of time, academically, rationale-wise, content delivery network, fast network, caching. So we'll talk a lot more. Realize content delivery network can help with security a lot, especially with regards to DDoS attacks. So look at it this way. If my web server can request the same page being served 1,000 times per second, and 1,000 people per second are requesting the same web page, and the same web page goes to the content delivery network every time, and the content delivery network has it stored every single time, those 1,000 requests never touch the web server. So if your server can only do 1,000 web requests, but you get 5,000 web requests from a hacker, and that web requests are legitimate web requests, and they all go back to the user, the server's still not doing anything, so the server's like DDoS. So caching can help with DDoS, and we're going to walk through a lot of it. And content delivery networks can also help a little bit with availability. Now, I'm not going to call this a high availability solution, but it can help. So let's say I've got a web page, www.gocloudcareers.com. Let's say it's all cached in my content delivery networks, and we'll talk more about that in a minute. Let's say my web server takes a nap and goes to sleep, or gets shut off, or my cat unplugs my web server, which my cat Cindy loves to unplug my server. She's real cute. She does it all the time. She unplugs my server and she powers things off with her little paws. So she does this. My little kitten powers off my web server. And then my web server is cached in the content delivery network. So somebody goes to www.gocloudcareers.com and it's my web server is down, but it's still cached on the content delivery network. So the users are still getting access to the content. So it's enabling me to increase performance and availability and reduce the load. So content delivery networks are important, and you should be using them everywhere because of the performance enhancements. So dramatic improvement to your hosting performance, and it can dramatically reduce latency, dramatically improve user experience, and reduce the load on your servers, which can actually decrease your costs. So better performance, lower overall costs, huge win, everybody. So content delivery networks everywhere. So let's talk about how caching actually works. And let's actually walk you through it so you truly get it, because this caching content is really, really essential. So here's the way caching works. Here I am. I am the client sitting over here. I want to go to a static website. The static website is hosted in S3. So I go to my browser and I want to go to www.gocloudcareers.com. So I type that into my browser. I get redirected to the content delivery network. When I hit the content delivery network, if the message is stored here, it gets instantly sent back to me. But I request it from the content delivery network. It's not there. So then I go to the regional cache, which you can't see here. And if it's not there, then my request gets sent to the original source. My original source responds, drops it off at the regional cache, which is here, drops it off at the Amazon Cloudfront location, and then sends it back to the server. So the first time, and this is called a cache miss. So if you see a test question about a cache miss is when you go to the cache and it's not stored there. So the first request for this content goes to the content delivery network. If the content delivery network has it, it sends it. If it doesn't have it, in which case there is a cache miss, then we send it to the regional cache. And if there's no hit there, it misses again, we send it to the original source. Then we send it back to the regional cache, which caches it, then back to the local CloudFront edge location, and then we send it back to the user. Now, my wife goes to the same website from my same house. She hits the CloudFront delivery location, it gets it back. So poof, it's back. Now, I want you to really understand two things have occurred. For the second client, this got fast. Because what if my web server is hosted in California and here I'm in Port St. Lucie, Florida? So if that's the case, then it speeded it up, because instead of my request going to California, I only went to the Miami CloudFront location. So first, it speeded it up. But secondly, I want you to see this. When I hit the CloudFront content delivery network, I'm jumping on the content delivery network. Amazon owns this content delivery network. Because Amazon owns the content delivery network, Amazon can guarantee the performance of your traffic on the content delivery network. So because you're on a private network, not the internet, Amazon can also give you better network performance getting to the source. So not only are we getting caching here, but we're getting better networking, higher performance networking, lower latency networking that's going to do a better job, because we're not dealing with internet bandwidth, we're dealing with private network bandwidth. And if you recall why we talked about we use direct connections versus VPNs, guaranteed performance versus best effort. When we're using these content delivery networks, we're gaining a lot of the same benefits that we would use by using a private network, because it is a private network. So everybody, CloudFront, it is your friend. CloudFront will reduce the load on your servers. It'll enhance the security. It'll increase your availability. It'll increase your performance, and it will decrease your costs, especially when you're dealing with inter-region transfer charges. Because you got to remember, when you're dealing with the AWS cloud or any cloud, when your traffic goes between regions, they charge you, and it gets pretty darn expensive. So we can save the inter-region transfer charges through the network of caching servers. So this is why content delivery networks are so widely used. So let's talk about it. Let's talk about the scalability impact. And I know I talked about it. If a web server can handle a certain number of requests, that's all it's going to be able to do. And then to be able to handle more web requests, you're going to either have to use a bigger server or add more of them. Why do we use load balancers? So we can use 30, 40, 50, 5,000 web servers to get the job done. So that's why we're using them. So the greater your content delivery network, the greater the more you can offload your information, then the better your performance is going to be on your servers, because they're not going to be busy. They're going to be sitting around like my cat, lounging around on her back, cleaning her fur or whatever the kind of thing the cat does when she's, relaxed. She's going to be just playing. So servers are going to be relaxed. We like our servers relaxed. We like our server CPU to be low. We like our servers memory utilization to be low. We like our servers as if they're chilled out on the beach with their sunglasses relaxing. That's a healthy server. When the server CPU hit 100%, we've got problems. So let's keep our servers relaxed. Let's cache. Let's use content delivery networks. So That's why we use this. Now, let's talk about caching. Caching stores frequently utilized content. Frequently utilized content. So, if it's new content every time, the cache will not help, not at all. So, caching is good for content that is repetitive. So, keep that in your mind. Caching only works with repetitive content. Now, when we're dealing with AWS Cloudfront, it works with a tremendous amount of the AWS services, and Cloudfront is a really great content delivery network. So it works with EC2 instances, provided they're front-ended by a load balancer, or you can front-end a static website. If you've got a website that's basically static content, stick in an S3 or object storage, front-end it with a content delivery network, and you've got a beautiful serverless, extremely cost-effective, simple to maintain website. I mean, it's great. No servers, nothing. And guess what? With the CDN, it's going to be relatively inexpensive because you're not going to have a lot of interdepartmental transfer charges. I'm sorry, inter-region transfer charges. Why? Because the CDN is going to do it. Now, granted, you're going to pay for data transfer on the CDN, but all in all, it's not a lot of money unless you've got a lot of traffic going back. So remember, can front end an S3 based website or an EC2 based website, but you have to have a load balancer to use Cloudfront. So let's look at this architecturally speaking. In this particular environment, what I've drawn is a hybrid website. It's got a lot of static content, rich media, photos, videos, and it's also got dynamic content. So the dynamic content we have on our EC2 instances, we've got them front-ended by a load balancer. We've got our static content in S3. We're pointing that to CloudFront, and CloudFront, it helps distribute our content all throughout the internet. So we love it. It's a great service. So let's talk about some key CloudFront concepts. When you set up CloudFront, we're going to be dealing with a distribution, an origin, and a cache control. And both you will need to know these for the exams, whether it be the Certified Solution Architect Professional or the AWS Advanced Networking. But more importantly, you need to understand this to be an actual cloud architect or a cloud network architect. So regardless of one of these two roles, you're going to need to know these. So we're going to talk about them: distributions, origins, and cache control. So let's first talk about the distribution. When you set up CloudFront, you set up a distribution, and the distribution is going to be identified by a DNS name. And I'm going to tell you, it's going to be the ugliest name you could possibly think of. Amazon is going to give you a really, 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 really ugly name. And what it's going to look like, it'll be like an ABCDEFG 123411111.cloudfront.net. And that's going to be what your new DNS name of your website is going to be. So you've got two options. You can choose this ugly website. I wouldn't. Or you can create a CNAME record, map www.gocloudcareers.com to abcdefg11111.cloudfront.net. And that way you've got a usable name. I'm going to tell you this. Businesses will need a human, user-friendly name. So when people use CloudFront, they need to create a CNAME record too, mapping a cool name that a human can remember to the ugly name of the CloudFront distribution. So just bear that in mind. Now let's talk about the CloudFront origin. Origin, for example. When you set up your CloudFront origin, the origin is really the location of where your content is coming from. So if you're dealing with S3, if you're dealing with an EC2 instance, if you're dealing with an elastic load balancer, that is the origin. So the origin points to the DNS name of the location. So just keep that in mind. So let's talk about the cache control. So when it comes to the cache control, whenever you're dealing with a caching environment, you have to deal with cache control. And here's what I mean by this. If we have a content delivery network. And this content delivery network that we have going on is storing information. It means it won't go back to the server, which is great. But what if I change the web page? If the content delivery network is storing it in a cache, do you know what's going to happen? New people might not see your new website. So when you're dealing with this, when you're actually dealing with the content delivery network on the website, we don't want the stale data to be in the cache forever. So what do we do? How do we make this better? We do it as follows. We have a cache control. Now, the data in the cache by default is 24 hours. So we've got a 24-hour cache. So if somebody hits my Go Cloud Careers website, they're going to see that same page for 24 hours before the cache times out, which means I'll have old data potentially for upwards of 24 hours. Now, because of this, my server won't be requested from that same cache location for 24 hours. So that's kind of how these things work. So that's how the cache works. Now, if I make a change to my website and I want the world to see it, I could clear the cache and then everybody would see it immediately. Of course, that'll clear the cache and then all the new content is going to be rushing to my servers. Now, if I chose to use a shorter time on the cache, which is called the time to live until the content expires, realistically speaking, I could change it to 1 hour, and every hour, new content is going to be there. But if I change the TTL or changed how long information is going to be seen in the cache, if the cache ages out in an hour, inside 1 hour, the content's going to go requested to the server. So the longer the timeout in the cache or the time to live TTL, the less work your servers do because it's stored in the content delivery network longer. Now, if your servers do less work, old data will be there. So you as the architect need to work with your client and say, how often do you change your website? How often do you change your content? When you change your content, then, and only then are you actually in a position for new people to see it. So these are going to be the kind of things that you have to do. You have to make sure that the cache is optimal for these kind of things. So that's what we're doing. Now, with regards to Cloudfront, we're going to set up our web servers. We're going to put our content on these web servers, and then AWS will assign a domain name to those servers. And like I said, we can either accept it, which we should never, or we can create our own CNAME record and AWS provision it. So let's walk a little bit through and look at some of these architecture environments now that we know what they are. So let's look through what these look like. I know we covered in this at the beginning, but I want to make it really, really clear. So here's what we have. We have the user, which is going to access the edge location, and I'll show you in a minute. And the edge location, realistically speaking, is what connects directly to the region and all your availability zones. So the edge location, and there's going to be an edge location in every major city. I think there's 217 or 227 of these better through, but realistically speaking, these would be there. So Mark Barry, the reason we're not doing hands-on configuration is we're training architects, not engineers. Architects are system designers, and system designers need to design. If we go hands-on, we won't talk about design. That will put us into the cloud engineering world, which is great for cloud engineers, but not good for cloud architects. So there's a reason we're talking about the concepts. The reason I want you to understand them, because I need you to be able to design them. Now tonight, as I mentioned, we'll have somebody teach how to configure them, but that is for the cloud engineers, not the cloud architects. The architects are the system designers, the engineers are the builder. So that's why we're talking about how to design right now, because we're focused on building architects. We are a cloud architect-based company. We are not a cloud engineering-based company. Now, we do have a cloud engineering program in development. I've reached out to one of my friends that I know to be an incredibly good cloud engineer making them, but as a company, we're 90% architecture work, and I teach architects, not cloud engineers. We will have a cloud engineering program, and we will do it that way, but that's why we are focused not on PowerPoint slides, and that's why we're focused not on hands-on configuration. We are focused on architecture work, because architects don't code. Architects don't configure, architects design, and I need you to have great design skills because we want to get people cloud architect hired. So please keep that in mind. But I do have some people coming in tonight doing some cloud engineering work, assuming we don't have a run into a medical emergency like we did the other day. So let's now go back and let's look at it one more time. The user wants their content. When the user wants their content, they go to the edge location. And the edge location has it, they get it. If the edge location doesn't have it, they hop onto this regional cache. And they don't really talk a lot about that regional cache. You can look up the regional cache. There's not a lot of information on it, so I don't have any answers for you, but I know it goes to the regional cache. AWS documentation, not exceptionally great, very sparse on details. But any of the cloud providers' documentation has to be sparse on details, and it has to be for a reason. They're dealing with logical services, and they can change them all the time. So there's a reason for this. But the user hits the edge location. The edge location will either have it, give it back to the user. If the edge location doesn't, it sends it to the regional cache. If the regional cache doesn't have it, it goes to the source. When it goes to the source, then it goes back to the edge location, or the regional cache, back to the edge location and back to the users. Now the next user that comes here, it'll be stored here. Now let's say this is Miami. Let's say this one in the middle is New York. If the user requests a page for the first time in New York and it's not there, it's going to go here. It's going to hit the regional cache. It's going to go back to the source. It'll go to the regional cache and it'll go here. Then it'll go back to the user. Now, the next time the user needs it, they won't have to go here in both New York and Florida. But how about here? Let's say this is San Jose. It's not going to be here either. So the user in San Jose is going to have to hit the CloudFront edge location. And if it's not in the CloudFront edge location, then it's going to go to the regional cache. If it's not there, it's going to go to the source. It'll go back to the region, it'll go here. So this is what's going on. So note, it's content. So when you see these black lines here, note that means a network, because we're now jumping on the AWS network, which is different than the internet network. It's under AWS's control. And because it's under AWS's control, we're going to be in a different position. So, and we'll walk through some questions on this in a minute. Now, you can use content for private CloudFront for private content as well. So, realistically speaking, when you're using CloudFront, you can use it to serve a public website like we normally do, but you could use it for paid website subscribers or private applications. Think of Netflix, private content, still using a content delivery network. And if you really think of Netflix, I want you to think about how elegant the solution is. You stick a company like Netflix. They stick videos in object storage like S3. They front end it by, CloudFront. For the most part, their static content is completely managed without a single web server. Now, they're going to have web servers and app servers and massive databases to know where the users are and where they are in their videos, to keep track of it, to keep state. So granted, they're going to be using massive NoSQL databases and they've got everything else along the way. But they're serverless for their content because CloudFront enables them to do this really, really great private website, private applications. And the way this happens is they restrict their content. So they restrict it with an origin access identity, which enables you to restrict the bucket to certain people. And you can use signed URLs, you can use signed cookies, and that's how it's going to work to give access to content. So we're talking about signed URLs. Let's talk about the expiration times of these kind of things. When we talk about the expiration times of these signed URLs, let's make sure we know what it is. So what are we talking about? If you sign the URL with your key to give it to someone else with your IAM instance profile, it's good for about 6 hours. If you sign it with the token service, it's good for up to 36 hours because it's more secure. If you pre-sign a URL with an IAM user account, it's good for up to a week. And if you issue a temporary token, it's good until the token expires. So these are the reasons why we do these kind of things. So let's talk about a little more. So 217 points of presence where CloudFront is at the time that I mentioned it. Lastly, we'll talk about the content caching. Remember, we're talking about routing efficiency. And we're also talking about something called persistent connections. Basically, the CloudFront's going to maintain a connection with the source. And by that reason, there's no reason to start new sessions with the web servers for every request. So things get a lot easier. So let's talk about how CloudFront can help protect DDoS attacks. First, it's going to distribute the content across the world without going to the web server for frequently accessed information. So it's going to reduce load on the server. What is a distributed denial of service attack? When you overwhelm the server with requests beyond its capabilities. And there's lots of other ways to do it, some with legitimate, some with illegitimate traffic. But if legitimate requests get answered by the content delivery network and not the server, CloudFront helps protect against DDoS attacks. Now, CloudFront will only forward legitimate web requests. So if it's a bad request, it's not going to go to the server. So by that, we're keeping the bad request from going to the server, further reducing the workload or the ability to launch a DDoS attack. So the attacker can't send these bad requests to the server because CloudFront will drop it. So half of the hacker's tools are blocked immediately here. Now, CloudWatch can also provide some encryption in transit, so it can enforce SSL TLS protocols, and it can integrate with the certificate manager. So you've got a lot of additional security things that we're really talking about. So these things get kind of really impressive. So I'm going to talk a little bit about Lambda at Edge very briefly for like 2 minutes, and then we're going to answer some questions. And the reason I'm going to talk about Lambda at Edge, as Lambda at Edge is kind of sort of part of this CloudFront kind of concept. So let's talk about it. What is Lambda at Edge? Look, it's a way to do Lambda functions close to the user. So simple, basic function. Lambda is the service environment that enables you to do a couple little mini automation things. And the Lambda at Edge just means running your code close to the user or around there. So Lambda is this basic serverless computing service. Basically, you write a little bit of mini code, and it's basic code. It's not for anything significant. It's for little simple things. Organization writes their code in C#, Go, Java, Node.js, Python, and Lambda is just little simple functions like automation functions. Lambda is stateless. So basically what happens, if it performs a function, when it's performed and completed, it's done. If another function needs to occur as a second set, it will be necessary to just set up a second function. So anytime you want to do automation, remediation of a security defense, patch an operating system, process data, this realistically speaking is where we're talking about with Lambda. You know, you've got an event going on, such as a new file goes into an S3 bucket, and maybe you want to notify someone, maybe you want to send the file someone. For example, we do a lot of video processing around here. And we could create a Lambda function, for example, that would do something like this. I could upload a video to an S3 bucket. I could have a Lambda function that sends it to Amazon Transcribe to make me a video transcription. I could then send up a Lambda function to send it to a server to optimize the video. And then I could have a Lambda function kick off an SNS or an SNS service to send me an email that says, guess what, Mike, download your thing. So these are, realistically speaking, some of the kind of questions, things that we can actually answer. 1 second. So Chris, if you'll bear with me, and then we should open it up for some questions. But also, Chris, I sent you a message in the chat box. Okay, Chris, if you want to start bringing in some questions. Although it protects our web servers, is there a restraint capacity? At some point, every organization, there's always a capacity limit. There's anything in the world that's without a capacity limitation. There's usually standard ones, and then sometimes if you need beyond that, you can actually call and request more. But there is definitely a capacity constraint on every system in the entire world. Chris, if you want to bring in the next one. There may not be that many. Is the regional level cache another big CloudFront that would store information assimilated from local cache? Or is it another hop to reduce web server access? Well, our theme with anything, and again, AWS does not publish a lot of information on the regional caches, you want scalability. So when you design a network, you have a core that does the fast things, you have a distribution layer, and you have an access layer. So you've got local caches in the area. Why do you have local caches? That's what the user access. If you put the local caches to a regional cache, they have a place to go. And by putting it there, less requests will actually have to go to the server. So it's the same thing with the network, with the core access distribution. Feed them into the system with the edge location. The regional cache would be where all the edge locations go, so they don't actually have to go to the web server. And then if the regional caches don't have it, then send it to the web server. So it's a way to be much more scalable, to reduce the load on the servers and to make the content delivery network scale. Remember, decouple, decouple, decouple. The more decoupling you have, the more problems that exist in one area don't exist in another problem. So it's like anything else in networking. We decouple to promote availability. We decouple to promote scalability. We decouple it and make sure that problems that occur in one area don't exist in another area. They call that limiting the blast radius. We decouple due to security purposes, and we decouple to reduce the load on the servers. So when we're dealing with these architectural situations, it's not one thing. It's a combination of a multitude of factors that we're trying to do with our architectural decisions. And by doing it that way, those are the benefits that we've actually received. Chris, if you want to bring in the next one. Does CloudFront store content in the edge locations? Well, those caching servers have RAM in them, and they will definitely be storing some of your content in their DRAM and drive. So the answer is yes. Asim Hans, can there be a way of setting where the cache can detect any changes being made on the web servers and automatically refresh them? No, the thing with caching is it's got a timeout and a TTL for a reason. The reason it has a TTL for a reason is to protect against extra workloads. So no. Now you can clear the cache should you have a change, and that could be done, but no. There's a reason the cache is designed this way. There may be some ways that you can override a traditional cache, but you really don't want to do it. You want these TTLs to be what they actually need to be. But if you have a change, you can clear the cache, flush the cache, and the new change will be propagated to every server everywhere in seconds. Leo Proudies, let's suppose you use Akamai CDN. Good. Do you have access to the logs from the servers to allow me to verify where your traffic comes from, which client you are as possible? I am not an administrator. I am an architect, Leo, but generally speaking, you can get some relatively good content and good statistics. But I'm an architect, not a hands-on configurer. So because I'm not part of the operations group, like the sysops people, because architects and operations people are very, very different, I don't get to look at operations data to actually see things. Those people in the maintenance world, in that sysops world, are going to be looking at capacity planning. They're going to be looking at link utilization. They're going to be looking at logging to determine if they need more capacity and things like that. Those guys or girls or whomever, they will do all those capacity planning things. They will file reports. By the time reports get to us as architects, it's just information for us to look at. Then we can say, okay, this now tells us we need bigger servers. We need bigger this. We need bigger that. So Leo, by the time I've never done that to be able to answer that intelligently, because I'm not an operations person, I'm a system designer. But assuming you do, most likely your sysops people, your operations people, your maintenance people will have access to seeing what's going on. Because you've got access to your network. Typically you would use NetFlow, but on AWS you can use flow logs, your VPC flow logs. That's going to give you a lot of information and show you your traffic. And there's also ways on your web servers, you're going to see where your traffic is, because they're going to be running tracking cookies. So organizations will have things like Google Analytics, and the Google Analytics is going to tell them where their users are, how long they've been on their page, what they've touched while they're on their page, and they're going to have Facebook pixels and a lot of these things. So there's going to be a lot of ways the organizations are going to be tracking where their data is coming in from. Not just that, Leo, they might have some clickstream data from all these things. And in addition to that, on the data on the page, they may be streaming that into Apache Kafka, or they may be using things like Kinesis to also look at the clickstream. So, Leo, there are a lot of big data environments that can be put in here to analyze this. But from my world, it's not a world that I've got any experience, and I don't want to give you an incorrect answer. So that's how I would answer that. Tech Mufaz. Lambda is basically small automation, exactly with Mufaz. You're not going to put a web server on Lambda. You might say if you upload a file, a Lambda function might be email somebody that it's done. Or if I make a folder, if I upload something to S3 public, a company might have a Lambda function that scans new files if they're public, email the user, tell them to make them private or something like that. So to be sure, Lambda is for very small stuff. Jeannie, the TTL is for all content, static and dynamic. TellerMe Media. If you have a streaming application, wouldn't that imply dynamic content delivered at server side? Does the TTL to apply both static and dynamic? Cached content, static, dynamic, is both going to be there. Now, having said that, well, there's certain things that are static and certain things that would be dynamic. But the streaming service is a video. The video is not dynamic content, it is static content. It's a .mov, a .mp4, it's an MPEG-4 kind of file, which is typically compressed with an H.264 or an H.265 codec to do this. So it is static data. It looks like dynamic data because you see it changing, but it's actually static data because it's video. It's a file. It's not actually dynamic data. It's not live people that are talking, which is different and moving. It's pre-made and pre-done, so it's static data. King's Kids, is pre-warming a bottleneck when trying to mitigate a DDoS attack? Pre-warming a bottleneck makes sense if you're going to have a Christmas sale on Black Friday, the busiest shopping day of the year, called Black Friday in the US, the day right after Thanksgiving when everybody goes shopping. Pre-warming your load balancers, pre-warming your servers, and doing a scheduled auto-scaling ahead of time. Yeah, totally makes sense. Totally makes sense. Totally makes sense in every way, shape, or form. Totally. But if you had a DDoS attack, you don't have to pre-warm anything, because here's what's going to happen. Ideally, King Kids, and if you want, we'll talk about DDoS mitigation. First, your DDoS should stop it, and it won't. Then your firewall should stop it, and it won't. Then your IDS IPS system should stop some, and it'll stop some, not others. Then your network ACL should stop something. Then your security group should stop something. Then your host-based firewall should stop something. Then hopefully your servers are locked down and don't even have unnecessary services. Hopefully your content delivery network stops stuff. Hopefully your systems auto-scale to keep meeting up with the capacity of demand. So all these things are what you're really going to do. Just necessarily set up auto-scaling. The auto-scaling is going to happen on its own. And you're not going to know when the DDoS attack is going to come in to say, hey, I'm going to be attacked in 30 minutes. Let's scale out let's pre-warm our load balancers. So in theory, if you could do it ahead of time, it would help. But you're not going to know when you're going to be attacked ahead of time. So it's not really an option for you to do it that way. What about encryption? The content delivery networks do support SSL-based TLS encryption. But that's, that's whether you set up the web page as HTTP or HTTPS. Old time honey official. Do Lambda functions always have a slow startup time, or is there a way to avoid this? I don't know if there's necessarily a way to speed them up a lot more, but they're not meant to be the most rapid things in the world. Shakir, are there any other tools like load balancers and Cloudfront to protect against DDoS? Yes, Shakir. Firewalls protect, load auto scaling protects, Shield protects, auto scaling protects, access control list protects, security groups protect, locking down the services on a system protects, IAM protects. There's a whole lot of things. Having policies that can look at things and actually see traffic that doesn't look like legitimate traffic, all those kind of things protect. How does Cloudfront protect DDoS attack by denying illimited traffic? Okay, does Cloudfront have its own firewall? Check with Mufaz. What's going to happen is when you get an illegitimate request, an HTTP slow read, a ping of death, or you start to see things, there are patterns of behavior that don't look right. Now, if it doesn't look right, it doesn't mean it still doesn't need to be processed by the server and then dropped by the server after it's processed. But by stopping at the Cloudfront server, it's going to look at it and say, bad, don't send it to the server. So if it doesn't send it to the server, It's kind of like having a security guard in front of your house. Somebody wants to knock on the door, they go to knock on the door, and the security sergeant says, go away. So that's realistic what's going on. Keep the bad guys away from you. Keep the bad actors away from you. You don't have a problem. So that's how Cloudfront does it. It actually has, just by nature, content delivery networks won't forward bad requests. But on Cloudfront, you probably are going to put AWS Shield, or better yet, Shield Advanced, which is a DDoS mitigation strategy. So in addition to the natural protection that's afforded by content delivery networks, you're running a DDoS server. Akamai has it, Cloudflare has it, AWS has their Shield, Azure's got a DDoS protection, Google's got Cloud Armor. They all have their own DDoS protections on their own content delivery networks. Because content delivery networks are so good at reducing DDoS attacks, and not only are content delivery networks so good at reducing DDoS attacks, but what content delivery networks are actually good at is actually saving web servers and these kind of things. So understand these are the kind of things that we're going to see very frequently going on from a lot of different environments. So I hope I answered your question over there as well. Varun, is it a good idea to prepare for architect level without having any knowledge of the associate? Like congratulations, etc. GUI knowledge. So I think you need to understand what the job is, Varun. And I do think you should, in your own time, go build these things at least once, twice, because you have to be able to tell people that you can do it. But here's the thing. As an architect, you must have an extreme knowledge in business transformation. Here is the thing, and I mean MBA knowledge or better. And I'm not saying you have to have an MBA, but you need MBA knowledge or better. You have to be able to present to the executive. You have to speak the executive language. You have to present like a director or VP level individual. You have to know how to do ROI modeling. You have to know how to sell. You have to know how to negotiate. As an executive, you need director level skills above to be able to do these things. So that's 50 or 60% of the job. If you spend too much of your time configuring, you won't have the time to actually learn the skills that are necessary for the actual job. So I will tell you, the last 1,000 people I've interviewed, none of them were hireable. And they weren't hireable because they didn't have the non-technical skills to do the job. So it doesn't matter how good your technical skills are, it's your non-technical skills. So given that there's a limitation, given that it's going to take you a good number of hours, I mean, I spend 500 hours to train somebody to be a cloud architect, and that's 480 hours past the certified solution architect professional. And that is giving them the architect skills. And in that, we don't even have the time to configure in that time. So because of that, it takes that many hours to be good. So yes, I think it's great, go configure. But realize the configuration is secondary to knowing how to design. We architects design, we don't configure. I've been an architect for 25 years. The last time I configured something was about 25 years ago when I moved from engineering to architect. So you have to know how to configure it. You have to know how to build it. And you should practice building it. But Varun, I have my students build a cloud, because it's a whole lot more to build a cloud from scratch and design a cloud and build a cloud than it is to set up an EC2 instance, which I can teach an 8-year-old to do in 3 minutes. And I have. I've taught an 8-year-old to set up an S3 bucket in less than 5 minutes. I've taught an 8-year-old how to configure an EC2 instance on the GUI. And that's great. And when the 8-year-old does it, she's really cute. She says, EC2. But I'm not going to pay someone $150,000 to $400,000 a year to do that. I'm going to pay someone to design the systems that are going to save a bank $1 billion a year. I'm going to pay someone that can take somebody that has outages every day and fix the outages. Those little mini skills, they're not architect skills. So that's why when we train architects to be architects. When we train cloud engineers, we train a lot of hands-on building. But train for the job you want, get the job you want. Train for somebody else's job, get their job, not your job. So that's why there's that. Chris, did we have any other questions? Otherwise, we'll go back to the content.
Mike, we always have questions. There's never a question of if we've got questions. It's, I mean, we can keep going down questions, but we'll always have questions. So okay. Do you want to keep answering questions, or would you like to?
Let's do some security work.
All right.
And then after we do some security work, let's really give some people some chance to ask some questions. Because we actually have some time built into the system between today and tomorrow. We've been making some really good progress. So I want to know that everybody's questions get answered. But right now, let's talk about securing the cloud. And when I plan to do this with you, here's the way I plan on going through securing the cloud. First, we'll talk about security. Then we'll talk about the AWS security. And then we'll talk how to really lock it down as if your life depends on it. Does that sound good for everybody? First, we'll talk about security. Then we'll talk about the AWS things. And then I'll teach you how to do it as if your life depended upon it, where if somebody got hacked, somebody dies. Because that's the real way to do it. Because I want you guys getting cloud hired, not just AWS certified. Certified, yes. Certified gets you the interview. Knowledge gets you hired. So let's talk about securing the actual cloud and the cool things you can do. We've got a lot of wonderful things that we can do. So let's begin. In this section, we're going to talk about securing your VPC. And we're going to talk about it from a network perspective, not necessarily an IAM perspective. For IAM, which is really important, or identity and access management, and we can address that when we talk about doing it together, please go to our free AWS Certified Solution Architect Associate or free Certified Solution Architect Professional program. The links for that can be posted in the link. But we're going to cover the AWS services that are going to cover the cloud, and then we're going to talk about the ways that you can do an end-to-end security architecture. Now, when we're going to talk about these AWS things, first, we're going to be talking about who's responsible for what. Then we'll talk about the principle of least privilege. We'll briefly address multi-account strategies. We'll talk about network ACL, security groups WAF. We'll talk about intrusion detection and intrusion prevention systems. We'll talk about distributed denial of service attacks. We'll talk about cloud formation. We'll talk about service catalogs and the systems manager parameter store. So we're going to be talking about a lot of things. Now, this area that we're going to talk about next, this shared responsibility model that AWS has, and all the cloud providers have it. It is a very good model. It is an extremely logical model, but this model causes a tremendous amount of confusion. And it's not just AWS. All the cloud providers have this similar model, and it's an excellent model, but it causes confusion. So let's make sure there's no confusion. Let's make it as clear as day. So let's talk about this concept. The customer, meaning us, the architect, and our organizations, we are responsible for the users that use the systems, the IAM users, which are people like me, and the roles, which are systems accessing systems. Predominantly, IAM roles change once we go from cross accounts and things, but typically think of IAM users as people and IAM roles as systems accessing other systems, like a service account. Customer is responsible for patching of the operating systems of their virtual machines or EC2 instance. The customer is responsible for maintenance and security of their own apps. The customer is responsible for configuring all the security options, like the firewalls, the network access control list, and the user. And the customer is responsible for the switch and the routers and all the devices, the physical security for the devices that get to the cloud. Physical security. So you've got a router at your data center that connects to the cloud. If anybody can plug into that router, they can connect to the cloud. So you've got to lock up your physical connections to the cloud, and it's there. Now let's walk through this. And when we're walking through this, let's look at the shared responsibility model visually. At the AWS side, they manage the servers, their storage, their master serverless databases, their networks. All that's done for you, and you don't need to know about it. You don't know about AWS's backbone. You don't know whether they're running OSPF or intermediate systems to intermediate systems. You don't know if they're using RSVP signaling and MPLS versus software-defined networking. You don't know. They're not going to tell you. It is hidden. They manage it. They manage their regions, their edge locations, their availability zones, all that stuff. Why do organizations love cloud computing? That stuff that AWS manages, that is 90% of the work. 90%. The reason it's so much easier to become a cloud architect than these other things is AWS does all the work. all the work, just the networking piece. To build the AWS network would take me thousands of hours and about 75,000 pages of reading just to teach people how to do the routing, just to make AWS's network possible. Without touching a server, without touching a load balancer, just the routing, not even the switching. That's exactly how much depth it takes to deal with just the network to build AWS, let alone their servers, let alone their storage environment, let alone all the control planes that make all this possible and the data forwarding plane. They do 90% of the work for you. 90% is done by the cloud provider. That's why organizations go to the cloud, because it's so easy and it's agile. All the work is done. So there's that. Now, the next part of this is what the customer is responsible for. So that is the organization's platform, their applications, their identity and access management, their usernames and passwords, the storage that we have. Are we encrypting our storage, our traffic? Do we have a network? Are we filtering routes? Do we have our access control list? Do we have all these kind of things that they're doing that? We manage the encryption. We have to manage our operating systems. We have to manage the configurations of our firewalls and our IDS and IPS systems. We have to do our routing. And of course, we've got to secure our data. So you can see here, AWS makes it a lot easier. Without AWS, we'd be responsible for the server management, the storage management, the heavy-duty networking, all of it, because we'd be managing the data center, along with the power and the cooling and the space and the racks, all of it. The cloud providers do most of the work for you. They make it really easy. So it makes it better. So let's talk about the principle of least privilege. So for those of you that have a tactical background or a military background, we know the term need to know. And need to know means if a person needs to know the information, they're given that information. And if the person doesn't need to know that information, they are not given that information, because if you have information that you don't need, you can accidentally or intentionally harm people. So need to know. Only give people access to what they need. And the second people don't need access, remove it. So AWS likes to take that need to know, and they like to call it principle of least privilege, which the reality is it's an extremely great way to explain this concept. Give people the minimum access they need to do their job, nothing more. The second they don't need it anymore, take it away. So if you're on an elite military unit, you might need top secret clearance. When you retire, you may not need it anymore. So these are the reasons what we're talking about. This is security, and this is the way you set up security in AWS, in Azure, in Google, in the data center, or the battlefield. Principle of least privilege. Now, the next thing we want to talk about is something called a multi-account strategy. So I know previously there were some questions, and I was talking about decoupling the environment, and I was talking about breaking it down into independent modules. So what happens in one organization or one environment doesn't affect somebody else. You want a secure environment? Decouple, break it into many little pieces. If you created an environment that has 1,000 VPCs glued together via BGP, you can isolate what happens in each VPC. So multi-account strategy is a similar way to do something different. What is a multi-cloud strategy? And again, these multi-account strategies, multi-account strategies. AWS was really smart with this. In order to help customers increase the security of their IT environments, they let them break their accounts into little accounts. Okay, so think about this. Instead of having a giant account, what if you've got a couple of little accounts? And then inside of each little account, you can isolate what happens in these little accounts. And then you can connect these accounts together with the policy. That way you could share the information that needed to be shared, but you can restrict all non-essential information. So if something happens in your New York metro, it doesn't have to affect the Miami metro. Or say, and it doesn't have to be geographically based. You could have finance in one environment and development in another one and test in another one and somebody else in another one. So really what we're talking about here, we're talking about making sure that we break it down, we segregate it, we decouple it, so a problem in one location doesn't have to affect a problem in another location. So that's the basis of a multi-account strategy. The way this works is all of the organization is placed into a single billing organization. And the reason this is done, whenever you're buying a lot, you get a volume discount. So you want to be able to aggregate all your customer accounts because you want that volume discount. So first, single billing organization. Then the billing organization, you break it down into little other things called organizational units. So each account becomes an organizational unit, which is basically a sub-account of the big account. And then what you do is you define something called the service control policy, which is a lot like an IAM policy that determines which organizations can talk to which other organizations and what their permissions are. So instead of applying like an IAM policy to a person, you basically apply a service control policy to the organizational unit. And what it looks like is basically you take your organization and you chop it up into multiple little organizational units. Unit 1, Unit 2, Unit 3, Unit 4. And realistically speaking, you let them communicate. You let them communicate by a policy that determines who can access to what. Here's another way to look at it from a hierarchical perspective. At the top, you've got the root account. Under that, we've got multiple organizational units and many accounts in each one. So the point of this is to decouple. It's to lock down. It's to secure. Note, everything that we're doing as we're locking down, as we're securing, as we're decoupling, we're doing all of these. And the reason we're doing these things is the following reason. We're trying to make sure what happens in one environment doesn't negatively impact another environment. And that's why we're doing it. So we'll keep talking about this concept. But if you're having a good time, if you could like, if you could subscribe, if you could hit the bell, if you could tell others, and if you could let me know that you're having a good time after you do all those things by typing #CloudHired in the chat box. Now, while you do that, and I get to know that you're awake, alert, and oriented, I will go back and start talking more about multi-account strategies. So let's talk a little bit more about multi-account strategies. They provide an isolation between organizational units, and they reduce the visibility of workloads between units. And the whole point is to truly compartmentalize data, to reduce the blast radius or the ability of what happens in one part of the organization to affect another part of the organization. And those are the reasons we're doing these kinds of things. We are making sure that we isolate the organization to protect the organization. And that's why we're really a big fan of these multi-account strategies. Now, when it comes to securing your systems, there's probably nothing better than the firewall. So part of your security posture, and like I said, we're going to map out a really nice security posture. We'll make it an architectural lab. Security is fun, and we'll go as complicated as you guys want. So generally speaking, security starts at the edge or perimeter of your network. So the perimeter of your network. So look at it this way. Let's say you had a castle to protect. Inside of the castle, you have the king and the queen. So we're going to do our security from the perspective of a castle. The edge of a castle is going to have a giant wall around the castle, a big wall. Ideally like big, tall, hundreds of feet wall, like 100-meter tall wall. And the reason you put a big wall around the castle is to keep things from getting in. So a firewall is what organizations use to build a wall around the castle. And the firewall lets internal traffic out and come back, and it keeps all unwanted traffic out of the network. At least that's what it's supposed to do. So what happens is at the edge of our network or the perimeter of our network, we choose a firewall. And a firewall keeps external traffic from coming in. It lets our internal traffic go out to the internet and come back. And the firewalls enable us to create demilitarized zones and things to put our things. The firewalls are security plans that limit where traffic can flow. So firewalls are going to be one of the key and most critical things to talk about. So keep that in mind. Now with firewalls, we're going to have two kinds. We're going to have traditional firewalls and we're going to have next generation firewalls. Traditional firewalls just filter traffic. Next generation firewalls not only filter traffic, but they are adaptive. They can see what's going on. They can recognize patterns of behavior they don't like, and they can act upon them like an intrusion detection, intrusion prevention system. So there's going to be a lot of great firewall options. Depending upon the customer, we're going to have two kinds of firewall solutions. We're either going to go to the marketplace, and for the majority of the customers that I deal with, I go to the marketplace because I deal with big global organizations that have extreme security requirements. There is also a cloud-native, very nice firewall solution made by AWS called WAF. And that can be used with Cloudfront, your application load balancers, and your API gateways. WAF is a light web application firewall. Right now, we're going to talk about WAF. Mind you, if you need extreme security or heavy-duty anything, you will most likely be going to the marketplace and getting something from Cisco, from Palo Alto, from Fortinet, or from Checkpoint, most likely. But if you can use the cloud services, AWS WAF is very simple, it's very elegant, it's high availability. You don't need to get into any complexities with network load balancers and gateway load balancers and load balancing virtual appliances. It is a very nice web application firewall that is great against common exploits. And when you're using a CloudFront distribution, a gateway, a REST API, or an ALB, or one of the application load balancers with AWS, it's pretty nice. And you can stick your WAF at these edge locations long before the content can even get on your network. So, keep that in mind. WAF and Shield go together pretty nicely. Now, when you're dealing with Amazon's web application firewall, it gives you relatively granular control over your resources because it's a firewall. And you control access through access control lists, rules, and rule groups. Basically, you make an access control list. They call it a web ACL, and that's basically you permit or deny based upon what you want to permit. And realistically speaking, we're dealing with rules, which are really statements that accept or deny traffic, again, like an access control list. And, they're rules. You can create something called a rule group, which is a group of rules that can be used in multiple places. And the good news with using WAF is it's very well integrated into CloudWatch, and CloudWatch kind of logs everything in AWS, so you can see what's going on in CloudWatch. Also, guess what? You'll be able to look at your flow logs, your VPC flow logs, and you'll be able to see what's going on. So, there's some benefits of using these nice AWS cloud native services. So how's it going to work? You're going to enable WAF on your application or device. You create a policy. Then WAF will look at your traffic and say, adheres with policy, permit. Doesn't adhere with policy, deny. And if an attack occurs, you just create some new rules to mitigate the attack, or hopefully. And you've got some good visibility. So let's look at what these things look like from a couple different perspectives. Here you're setting up WAF. You're popping it on either CloudFront, your load balancers, or your gateways. You're setting the policy, and you're just watching it. And, going back to our diagram that we would use here, in our load balancer, we're going to use a firewall, and we're going to put our DDoS protection. Then we're going to protect our subnets with a network ACO. Then we're going to protect our servers with a security group. And like I said, we're going to walk through each and every one of these. Now, when you're dealing with a DDoS attack, which is one of the more common attacks, you're dealing with layers. There's no one thing that does DDoS. I know there's DDoS services, but it's more than one thing. So let's talk a little bit about a DDoS attack. What is a DDoS attack? A DDoS attack is when you've got a hacker and they hack into a bunch of systems and they use those systems to send a large number of requests to you to overwhelm you or your server's capacities. So if a web server can handle 10,000 requests a second and you send 100,000 requests a second, we've overwhelmed the web server, and basically the web server won't be able to deal with anything. It'll just be responding to the bogus request. So let's look at, architecturally speaking, what it looks like. Here in the DDoS attack, we've got the attacker that's sitting over here. The attacker basically gets control of a server who then infects multiple other systems and then uses all these systems to actually attack this. That's a DDoS attack. So the reason it's not a DOS attack, like if it was a denial of service attack launched from this server to this server, is a denial of service attack. The reason this is a distributed denial of service attack is because we're distributing the load across multiple servers to hack into the environment. That's what makes it a distributed denial of service attack. So how do we prevent these things? Well, full security posture, firewalls at the edge, intrusion detection, intrusion prevention system, access control lists, keep traffic out of the subnet, security groups, WAF, shield, auto scaling, again. It's taken everything a lot. So how does auto scaling help? Well, if you've got 10,000, the ability to respond to 10,000 web requests per second, and you're getting 20,000 web requests per second, and you can have 3 servers that can each do 10,000 requests each, guess what? You can auto scale yourself out of the problem because you can create more capacity than the DDoS attack can happen. And that's why the cloud can be really great for DDoS attacks. In the data center, you'll run out of compute capacity. In the cloud, depending upon the way you set up your VPCs and your subnetting, you might be able to auto scale yourself out of the DDoS attack and stay out. Now, mind you, it's going to get pretty expensive to auto scale yourself out of the DDoS attack, but the cost of the auto scaling might be 1,000,000 times less than the brand damage from being hacked. So this is a good thing. And again, this is one of those environments where cloud technologies give you massive competitive advantage. So I know people look at me and I'm like, nope, this is going to the data center. This one's going to the cloud. This one's staying on the network. This has to go to the cloud. And the reason it is, it's that I look at what's in the best interest of my customers, as should every cloud architect. Sometimes it's a hybrid cloud. Sometimes it's a multi-cloud. Sometimes it's a single cloud. It's always going to be based on what's best for your customer. And you got to look at all these things. But the cloud and its ability to do DDoS and its ability to auto scale for web applications, it's almost like there's almost no other option. Stick your web applications in the cloud because it's so much better for web applications. So let's talk about the AWS DDoS protection or shield. There's 2 kinds of shields you can use. There's the shield standard, which is basic shield. According to AWS, it protects against 96% of the most common attacks. AWS is a vendor like everybody else. 96% sounds awfully optimistic to me. Every vendor is all a little bit optimistic about their numbers. So AWS is just as honest as everybody else. I'm going to believe them at 96%, but depends on how you do the testing. Let's just assume 96% is a little generous. And I would look at any vendor's numbers as generous because vendors' numbers are tested under optimal conditions and reality may be slightly different. But the AWS Shield standard is a very good service, very good service. It protects against SYNAC, reflection attacks, HTTP slow read, and Shield standard's your basic kind of DDoS protection. It's static. So whatever it's configured for, it's going to do. Now, when you get into Shield Advanced, now you're starting to talk about some really nice DDoS protection. This is much more substantial, and it's available at an additional cost. Now, this provides protection for load balancers, servers, Cloudfront, Route 53, you name it. And this is where you get intelligent attack mitigation and detection. So this is good stuff. This is going to be dynamic, like an IDS IPS system. And it's going to look for traffic patterns that are not right, and it'll deploy ACLs as needed. It'll send notifications, and it'll look, find, and potentially thwart layer 3, layer 4, layer 7 attacks. And when you're using Shield Advanced, you get access to the AWS DDoS response team, which is like 24/7, as long as you're on business or enterprise support. So Shield Advanced is really good, and it is some very nice DDoS protection. Now, I'm going to talk about CloudFormation because we're talking about AWS. I don't see anybody that would potentially want to use CloudFormation in today's world. CloudFormation, I'll talk about it from a security perspective, and then I'll talk about the alternative. CloudFormation is an AWS way to deploy things repeatedly. Terraform is the industry way to do it. Given that the majority of the organizations, meaning 97%, are using multiple clouds, not a single cloud, Learning how to use the AWS tool to automate things on AWS makes no sense to me. Learn the Terraform tool, and by using the Terraform tool, and we'll probably have a Terraform course coming out soon, but by using the Terraform tool, not for my architects, but for the engineers, but for the Terraform tool, it works on Azure, AWS, Nutanix, Google. It's going to work everywhere. So when we're talking about CloudFormation, I'm suggesting learn Terraform for the cloud engineers. For the cloud architects, we're not going to be using configuring. CloudFormation is not our skill. Terraform is not our skill. But for the cloud engineers, wow, they're going to be using Terraform. For the DevOps people, they're going to be using Terraform. So when we talk about these things, now, why do we like Terraform, CloudFormation? Here's one of the big problems you have. If you have a golden build, something that's straight and strong with all your vulnerabilities patched and all your unnecessary services turned off and everything hardened and locked down, that's what you want your server base to be. And you want everybody to use that so that everything meets a standard. And whether it's a CloudFormation template, which I love the theory behind, or Terraform, by being able to produce something in a repeatable manner with exactly what you want, you can substantially improve speed of delivery and security and performance, because you can go for consistency and the best. So CloudFormation is great for that reason. I'm just suggesting Terraform because I want the cloud engineers that are watching this to be able to work on any cloud, not just one, because I want them to have the best cloud engineering careers. So keep that in mind. But the concept of the CloudFormation template is great. Basically, you can make it the way you want and repeatedly launch it again and again and again exactly the right way. And I got to tell you, I've spent years running around with sniffers or protocol analyzers in my youth, trying to figure stuff that was on the systems. And then we find systems that we didn't even know exist. And they weren't patched, they weren't security compliant. We found holes and problems everywhere. By using Terraform or a CloudFormation template with a known good configuration that you've templated, you can make sure that your systems all meet compliance and are rock solid. And this is how you standardize and lock down your system. So templating these things is awesome. And your DevOps engineering team that's going to use this can really help you. These are really good, important tools. Now, CloudFormation templates, they're going to be available in a multitude of options. Basically, you set up your template or code. It's either in YAML format, like your containers, or JSON format. Basically, you write your code, you stick it on A3, and the code gets used by CloudFormation either in the console, the API, or the CLI. You basically give it your code. CloudFormation will provision your systems based upon the template, and then it'll deploy your template. So, it's a very great way to do it. Along with that, with regards to locking down your systems, is standardizing them. So if you can control, again, this all goes down to control what's put on your system, so people don't stick their own stuff. How else can you control it? You can use something called the service catalog, which is a fantastic AWS service. The service catalog is a means for you to create a list of approved services, maybe some machine images or servers, some software, some databases, some application architectures. Make it a standard, and you can control what's put on the network. By doing so, you basically have a catalog of things, which kicks off a CloudFormation template, and this makes sure that the appropriate things get built in the exact compliant ways you want them to. So anytime we're dealing with these kind of things, we're really getting into some great environments. So let's do this. We'll talk about the Systems Manager Parameter Store. We'll take a break for a few minutes. We'll answer some questions. And then when we finish the security section, we'll actually do some architectural whiteboarding. But let's cover the Systems Manager Parameter Store very quickly. When we cover the Systems Manager Parameter Store, it's basically an environment to store stuff that really matters. So there's certain parts of your environment that are going to be really critical. Your passwords, your database strings, your license keys. This is stuff you don't want to be getting access to. And if this kind of information is compromised, it can have a pretty bad impact on your security. So AWS gives you a relatively good option for storing your secret information, and they call it the Systems the Systems Manager Parameter Store. The Systems Manager Parameter Store is a scalable, hosted, serverless environment that's been optimized for storing passwords, database strings, license codes, and API keys. So just keep that environment. So if you've got some important secret things, use the Systems Manager Parameter Store. It'll separate your code from your passwords. It's going to give you an excellent, excellent means to audit your systems. It'll provide a method to track your password use, and it will substantially increase your security. Now, I know I went on there for a little while and we talked about some of these things, but I want to make sure that we answer some questions. So, Chris, if you want to bring in some questions, we'll answer some questions for about 10 minutes, 15 minutes, and then we'll go back to the content.
Okay, so we still have questions from the previous session that we have to get to.
Any questions are good questions.
Yeah, so it may not be 10 minutes. So one of them I held off because I knew that we were going to be getting to CloudFormation, but I'll bring it up just to make sure. Here we go. It's from Ken.
Ken, is it out of scope to mention CloudFormation? You've heard the term before, but it seems you confuse it with Cloudfront. But I'm answering the differences. So I think we just covered, but we'll do it. Ken, CloudFormation is the means to template a configuration and launch it basically infrastructure as code. So you've got a DevOps engineer, and the DevOps engineer is going to write it as infrastructure as code. And then when they write it as infrastructure as code, it's automatically deploy it. What I will say is, and I'll mention it again, I love the concept behind CloudFormation. And if AWS was the only game in town, I'd say that every DevOps engineer and every cloud engineer should become great at using CloudFormation templates. Having said that, given that the industry is going multi-cloud, Terraform for the most part is replacing everywhere CloudFormation. So I wouldn't pay too much attention to CloudFormation. I would spend a lot of time on Terraform if I was a DevOps engineer or a cloud engineer.
All right, and this next one also came from the previous question session, so it's old content it's referring to.
When there is a cache miss, what's the approximate time to wait until the user gets? It's instant, so it's not going to take any kind of serious time for anybody to notice it.
All right, and then the next one, I'm not sure if this is for this content specifically, or maybe we can point them somewhere else. Just let me know.
Mr. Wacko, is it possible to place a compute instance in a private subnet and can be accessed from a load balancer in a public subnet? Okay, Mr. Wacko, when you're using a load balancer in AWS, your web servers are always in a private subnet, and the load balancer is always with a public IP address. There's no other way that you can actually do it. So not only is it more secure, that is the only way you can actually do it. Which is a great question.
And I'm scrolling through all the cloud hires, so give me just a second. Okay, here we go. And this may have come in before you got in depth on CloudFormation. I don't know exactly.
Yeah, it seems what happens is a cloud architect like me goes to the DevOps engineer and says, spin up 80 web servers. And the DevOps engineer will spin up 80 web servers using a CloudFormation template. So all the infrastructure as code, all what DevOps people use is either using things like, well, a lot of what they use Terraform. Infrastructure as code would go Terraform, but CloudFormation is something that's very, very similar. What does a cloud associate do? You got to ask me at what company, Saeed. Associate realistically means nothing other than junior. So typically speaking, it could be anything. There could be an architect associate that would be a very, very, very junior architect. There could be a cloud associate that could be a very junior engineer. There could be a cloud associate that's a secretary that's called a cloud associate. So say it, I have no idea what a cloud associate is, because the word associate basically just means like junior, so, or entry-level role. So it could mean anything. So if you can give me the exact cloud role, then I can tell you what it means, like architect associate or engineer associate or account manager associate. But without that, the word cloud really doesn't mean anything. Imran, oh, you're from Persia. That's great. Can you participate in our boot camp? Of course you can. We've got students in Persia. We've got students from Persia. We've got a fair number of Persian students in the US and the Canada, and we've got lots of people. I mean, I don't speak Farsi, but as long as you speak English, yes, absolutely, you can participate, no problem. David Page, what is the difference between the systems manager and the secrets manager and the systems manager parameter store? You know, that is a good question, and I don't spend a lot of my time with regards to these. The systems manager parameter store protects your secrets, and the secrets manager also protects your secrets. So I don't necessarily have the best answer for you on that one. I'm much more Mr. Cloud than Mr. Just Pure AWS. Chris, if you want to bring in the next one. Can all firewalls are stateful? And next generation firewalls are stateful firewalls, but they also typically have some IDS, IPS systems inside there.
So I think it's safe to say that people don't want to ask questions because they want to get to the whiteboarding faster.
Okay, well, I love whiteboarding too. I think,
but I know we got some security to get through. But
we're going to get to some serious whiteboarding. We're going to have some architectural fun. And when we bring in my buddy, assuming his family's healthy, and when I spoke to him this morning, he said it was. When we bring in Imran, we're going to get to have some really, really, really fun cloud engineering kind of things tonight, if you guys desire, because I love my cloud engineering. I find it really, really fun. So we'll make sure we make it a lot of fun. Oh, and again, tomorrow, boy, are we going to have some fun. And there's a member of my team, really special guy, good friend of mine, somebody I know really, really, really well, and he's working really, really hard on building a really, really, really killer cloud engineering program. So I've tasked this person with it about a couple of weeks ago. I'm already blown away by what I've seen. So cloud engineering programs coming very soon. Excited to announce it. Half of what happened was I've been playing with all this tech, working with the Linux engineers and all these things, and I'm feeling like a child again. So the inner geek of me is coming out. So let's have some party. Let's get some more tech. So let's now talk about some other cool stuff. We talked about the service catalog so far. Where did we end up? Okay, I think we're now talking about AWS config. Okay, so AWS config is going to be a service that's going to enable the assessment, the auditing, and the evaluation of configurations in AWS. And AWS config is going to provide an opportunity to see what kind of changes were made and by whom inside of the VPC. So what's going to happen is when a change is made, AWS config will send an SNS alert to the system's admins, which is really great. So when somebody does something, you'll know about it. You'll find out about it. Imagine somebody makes a BGP configuration like at Facebook, and all the architects, the network architects knew about it, and the smart network engineers knew about it. And somebody went like, whoa, that's what happened. Let's fix it. So the point is, knowing what happened and when it happened is really great. Normally speaking, you should have a change management protocol, but things happen, mistakes happen. So if a change is made that violates an organization's SNS policy, we want to know about it. We need to know about it. So just kind of keep that in mind. So config is going to provide a means to assist with change management. It's going to provide a way to track relationships and management between resources. So if a change is made, you'll know who did it. We'll be able to integrate it with CloudTrail so people will be able to see. So how does AWS config work? Well, a change is made, config notes the change, it's going to record the change, and then config will check the change against the organization's policy. If it's good, great. But if it's not, the system's administrators will be notified that a non-compliant change has occurred. So real good protection here. So visually speaking, here's what it's going to look like. And I have way too many windows on my computer. They're open in all different directions. So, okay, it's going to look like this. You make a configuration change. It's going to monitor it, and it's going to hit logs, and it's going to tell you about it so you can figure it out. Now, let's talk about the certificate manager. When you need a certificate, an SSL TLS certificate, where are you going to get it? When you're dealing with AWS, you go to the AWS Certificate Manager, and it's a nice service to centrally manage your SSL TSL certificates. The certificate manager is going to add protection to the website because it's going to enable you to verify endpoints and establish some safe and secure encrypted connections. So the certificate manager is going to enable provisioning, very simply, management and deployment of your certificates. Now, your certificate manager is going to allow your users to deploy the certificates on AWS resources easily. So the way it's going to work is the certificate manager is going to provide free public certificates to AWS services such as your load balancers and your API gateways. So it's going to look like this. You'll go to the certificate manager, and it'll pop your SSL certificates, whether it be on your load balancer, your Cloudfront distribution, pretty much wherever you need it to be. So let's talk a little bit more about it. When you're dealing with the certificate manager, you're going to have two options. You're going to have the main certificate manager, which is where you're going to go to get encryption and security with TLS. This is going to be for external websites, whether you deploy it through your load balancers, your CloudFronts, your API gateways. This is for external facing, the certificate manager. Now with AWS, you also have the opportunity to go to the certificate manager, the ACM private CA. Now this is for communication private internal to your organization. So if you needed some hierarchy in your organization, if you've got private servers and you want to run SSL or TLS encryption from the user, maybe an HR app on an intranet to a user wants to update their social security number, their bank account information. It's an internal website for the organization, but they need to encrypt it because you still don't want it. So you would use the private CA, and you would use a certificate to encrypt an intranet website, not just an internet website. So these are what we're talking about. So keep that in mind. While we're talking about some AWS security services, we are going to talk about a few more. We're going to talk about something called Guard Duty. Guard Duty is an AWS service that kind of looks at your CloudTrail, your DNS, your flow logs. It looks for patterns of behavior, and it'll send you a CloudWatch event. And look, anytime you can aggregate logs and get better information, it's helpful. Now, whenever you're using tools that aggregate logs and give you information, the validity of that information is always going to be in question, but it's still there. And I don't care whether it's Guard Duty or I don't care whether it's an e-prescribing thing that I'm using to write a prescription for a patient. Systems that are automated give you automated alerts, and sometimes this information is so valuable, and other times you look at it and it's trash. But the point is you've got access to extra information, and it's going to give it to you, and it's going to help make you better. It doesn't get any better than that. So this is what we're talking about with regards to Guard Duty. So keep that in mind. A couple other services that are over here. Amazon Inspector. So let's talk about it. So what is Inspector? Inspector is an automated security service that helps improve your security. Okay, it does it by assessing your applications for exposures and vulnerabilities and deviations from best practices. Again, it's automated. So it's going to perform an assessment, and it's going to give you a letter of detailed findings. And then you, as the professional, will then look at these detailed findings, and from there, then you'll be able to figure out what you should do about them after looking at these things. So you're going to get some really good information. Again, you're getting great information here. So you'll know if something's not there. Now, the last one of these AWS services we're going to talk about is Macie. And Macie is another fully managed data security and privacy service, but this one uses machine learning and pattern matching to identify and discover sensitive data and protect it. So Macie provides an inventory of your buckets, your S3 buckets, for example. It'll provide a list of unencrypted buckets. By the way, S3 buckets being misconfigured is the leading cause of cloud problems. 16% of all cloud attacks happen from misconfigured S3 buckets. So this Amazon Macy service is a very good service, an exceptionally good service to help you identify and protect against these common mistakes. So keep that in mind. It's a machine learning thing. It'll match patterns. So let's talk about securing your VPC. Let's have some fun with it. Let's really whiteboard this out. So I'm going to whiteboard it out. We're going to have some really, really, really good enterprise security. So let's map it out, everyone, and let's enjoy ourselves. So let's do this. Let me describe what we're going to do first, and then after that, let's build it. The first thing we want to do is we want to keep traffic out of our systems. And how are we going to keep traffic out? Ideally routing. Then we're going to protect against DDoS. Then we're going to protect with firewalls. Then we're going to keep traffic out of our subnets. Then we're going to protect our hosts. So we're going to lock it down from every aspect. First thing though is keeping traffic out. Keeping traffic out. So let's first talk about Mike's first tenet of security. This is something that only network architects and network engineers will tell you. I'm going to tell you some of the best security is right here. If you don't have a route to something, you can't attack it. If you can't reach something, you can't attack it. If I want to go visit my friend Ian in England, and we want to drink a red stripe beer together and have some jerk chicken and some rice and peas together, and I want to go visit my good friend Ian over there, there's no road between Florida and London. So I can't get there by walking or driving or swimming. So I don't have a route. I can't hack my friend, and I can't visit my good buddy for red stripe beer, cod and aki, and say rice and peas or whatever I'm going to have for dinner with my good buddy Ian. My good buddy is Jamaican, and I love Jamaican food. So anyway, that's neither here nor there. Now, if I have an airplane, I can go visit my friend Ian. If I have a boat, I have of my friend Ian. Why? I have a route to it. I have a path to it. So when we start talking about locking down systems, we're going to map it out and whiteboard it out. If you don't have a route, you can't hack it. If you don't have a route, you can't hack it. So by just making sure you don't have a route, we fixed half of these security problems without even touching a security appliance ever. So only should you set up a route to those that need it. Okay, let's walk through some of these examples. I'm going to whiteboard these out because some of these things are kind of complicated. And while you'll never see me be one of those people, because I'm an architect, not an engineer, you're not going to see me hide behind PowerPoint slides. That's not the way architects present. If you tried to do that with a customer where you're behind slides and just presenting, the customer would basically find your replacement that would be giving the presentation. As an architect, you're going to be front and center. But having said all this, I want to whiteboard you through. So we're going to go to that corner and we're going to do these things together. So let's try to work on these things together. So let's look at it this way. Let's say, for example, I want to show you some basic security first. In most environments, you're going to have your data center. You're going to have your VPC. Now, let's say on your VPC, in your data center, you're going to have users, but you're also going to have users of your system. So now let's look at the users. Let's clean up this fill because I want you guys to all understand this, because this stuff is really important. So in your data center, you're going to have different kinds of users. Let's say you've got your cloud architects over here that are working. Let's say you've got a finance department over here. Let's say you've got some developers over here. And let's say you've got some operations people that manage the cloud over here. Let's say over here in the back, you've got HR, and let's say sales. We're just picking a bunch of departments at random. Now, in the cloud, we have some servers. We have the web servers. Web servers and apps. Now, who from this internal environment needs to be able to work on these web servers and apps? Let's think about it. Does HR need to be working on these apps? No. HR should not have a route to this. And the VPC should not have a route back to HR. Does sales need to know how to reach this? Nope. Sales shouldn't have it. Did the cloud architects need to get to this subnet to evaluate and baseline things? Yes. Make sure the cloud architects have a route in the routing table for this subnet. Did the developers? The developers do. Do the operations people? Yes. Do the finance people need to know this? Don't give them a route. Only allow these three, even network access to the subnet, by only sharing this route for these subnets. So if the cloud architects sit on this subnet, that's not what I'm supposed to be trying to do. If the cloud architects are sitting on the 10.0.0.0/24 subnet, the cloud needs a route back to that subnet. And if the developers are on the, let's give them, if the developers are on this subnet, we're going to make sure we have the subnet for the developers. Let's make sure we have a subnet for the operations people too. Do that. Okay, so now we've got this. Now let's say, for example, that finance's subnet, for example, is here. 10.5.0.0/24. I'm not going to send this routing information over here. I don't want them to know about it, because if they know about this route, they can reach it. They can hack it. But if they don't know about it, can't be reached. So automatically, these people are already kept off of the cloud because we haven't provided a route to that subnet. If you don't have a route to the subnet, you can't reach it. And if you can't reach something, you can't hack it. So lots of time when people talk about IAM and people love IAM, you know what IAM is? When somebody knocks on the front door in their house and they say, I'm here, let me in. And you look out the door and you say, I don't know you. You're not allowed in. You keep your door shut. That's IAM. What are we talking about over here with the routing? We're making sure nobody can get to your front door in the first place. So once somebody gets to your door, they can hit it with a sledgehammer, they can kick the door in. But guess what? If they can't find your front door because they can't reach it, because you don't live on a street, nobody can get to you. So the first part of security that nobody talks about other than network engineers and architects is don't give routing information to places that don't need it. If you don't have a route, you can't hack it. So lock your systems down. Start with the routing. Phase 1. Now, let's wipe this off. Let's lock our systems down. So at the edge of your web applications, you're going to have a CDN. At least you should have a CDN. So we'll pick a CDN. And temporarily, because I want to make all you guys employable multi-cloud architects, I'm not going to mention the name of a service. We will fill them in with Azure services, AWS services. Heck, we'll fill them in with Azure services too, because I want you all to know that it's all the same. Learn the cloud, not a cloud, learn the cloud. So we're going to start with our CDN. On the CDN, we're going to put some DDoS protection. Why? The CDN right here, bad traffic. Let's look at what's happening. Really bad traffic wants to hit the server. It's on its way to the server, and it's like, nope, bad traffic, block, 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 block. So we're not even getting any traffic to hit our systems. It's all being dropped by the CDN. So this is good. Now, behind the content delivery network, we need to protect our systems, so we need a firewall. Now, when we choose firewalls, we've either got a next generation firewall or a traditional firewall. For right now, because I want you all to understand the technologies that we use for security, what it is, how they work, why people use them, We're going to use a traditional firewall and not a next generation firewall. So we would use a firewall. Now, in our architecture that we're going to work with today, let's work on the assumption that if we get hacked, someone will die. So under those circumstances, we need some serious information security. We can't get away with amateur hour. We can't get away with small. We can't get away with commercial. We need big. Now, when we're dealing with the cloud and we need big security, big security, heavy security, here's what we use. We go to the marketplace. And on the marketplace, inside it, so if we go to the marketplace, we can get a deep enterprise grade security firewall. So that's what we're going to do because it matters here. So we're going to pick something really strong. So we're going to use a firewall that we're going to get from the marketplace. Now, I want you to think about this. Does this introduce any problems? And the answer is yes, it does. So if we get an AWS Elastic Load Balancer, it is a high availability device. It is a logical device, meaning it's not going to fail. When we use a WAF firewall with AWS, it's a logical device. It's high availability. We trust it. When we use an enterprise-grade firewall in a data center, we rack these firewalls in the stack. And when we rack the firewalls in the stack, they have a heartbeat between them and a high availability protocol. But last time I checked, I didn't have the ability to walk into the AWS data center, use my key, open the door, carry in boxes of servers, boxes of firewalls, rack them in one of their racks, have one of my engineers screw them in, cable it up, configure the firewalls, and then we leave the AWS data center and then we go out for dinner and drinks. We're not doing that. So because we can't get there, we have to go to the marketplace on all the cloud providers. And when we deal with these security appliances, we're dealing with virtualized appliances, virtual appliances. And because we're dealing with virtual appliances, they are not high availability. So if we need one EC2 instance running a Palo Alto firewall, we need two. Now, how? Somebody in the chat box tell me, what do you think we need to use two firewalls that are sitting in an EC2 instance? What kind of technology would enable us to share two firewalls at the same time to eliminate single points of failures? Type that piece of technology in the chat box if you know. What kind of technology can we use to send some data to firewall 1, some data to firewall 2? An intelligent device that runs a health check that's going to say, firewall 1, are you there? And the firewall responds, Apostolis, parapolioreo. Exactly. We're going to use a load balancer, Apostolis, Kenya Carl, Vivels. Excellent. We are going to use a load balancer. So when it comes down to it, we typically speaking, look at the kinds of load balancers. Now, when you're load balancing firewalls, when you're load balancing network appliances, you use a network load balancer. Remember, application load balancers are really slow. Network load balancers are really fast. So when you're dealing with network devices, you use a network load balancer. Now, AWS came up with a new kind of load balancer, and they call this load balancer a gateway load balancer, which is designed to load balance in between firewalls. There is not a lot of good information on this gateway load balancer. They don't talk about performance. They don't talk about specs. So there's really no good information why you should use that over a network load balancer other than they made it for that. So architects like me have been using network load balancers with firewalls for decades. So guess what? Whether you want to use a network load balancer, when you use a gateway load balancer, that is up to you. We are going to use a load balancer to load balance between our virtualized firewalls. So we're going to take an AWS Elastic Load Balancer, network load balancer, which is a very robust network load balancer. And we are going to use an NLB. And you'll see what we're going to do with the NLB. Then what we're going to do is we're going to load balance between firewall 1, and we are going to load balance between firewall 2. So let's look and see what we've done so far. I want to make sure you all get it. Security is important. First thing, the content delivery network. Someone tries to send a ban request to the server, blocked, 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 all day long, blocked. So nobody's getting there. Somebody tries to start a whole bunch of bad HTTPS requests. AWS Shield looks at it and says, no way, you're out of here. Requests don't go to the server. They never make it to the firewall. So nothing happens. We block 90% of it over here. Then for some reason, something gets to the network load balancer and gets to the firewalls. What are the firewalls? Remember I talked about putting a several 100-foot wall around the castle. That's a firewall. Now, I have my own way to describe security. I use all kinds of animals and knights and warriors, so we're just going to use my security. Please bear with me. I use some very unique names for my security services. So we've got the firewalls, which is this 300-foot wall around the castle, keeping the bad people out. So you've got some really bad attacker. The attacker climbs a rope. They climb up 300 feet. They climb the rope. They go over the firewall. They get past the firewall. They fall into a moat. The castles, they've got this area that's filled with water, and it's got like sharks and alligators and really scary stuff in there that eat you if you fall into it. So somebody climbs up. They get past the firewall. Then we've got another network device called an intrusion detection, intrusion prevention system. Here's what happens. So that bad guy, he breaches the CDN. He breaches our DDoS, he or she. Gets past our firewalls and then falls into the moat and gets eaten by some alligators and sharks. But let's say we've got someone that gets past the alligators and sharks. We're smart. We thought about it ahead of time. We've hired some Navy SEALs, some SAS commandos, and a team of trained lions. So that if anybody gets past that wall, first the lions eat the people, and if the lions don't eat the people, the SEALs and the SAS commandos kill them. So that's the next step. Now, what happens if for some reason this attacker gets past our firewall, that gets past our IDS IPS system, past our commandos? We still can't let the attack occur. We need more. So we're going to layer it. Then we're going to add a network ACL, and the network ACL is going to keep traffic out of the subnet. So this will keep unwanted traffic from traversing the subnet. So if anything passes, the CDN, the firewall, the IDS IPS systems, then we're going to get them. We're going to stop them with the access control list. Again, it's still not enough. We need more. Now, again, what we're going to do now, we're going to set up the security group. What is the security group doing? Security group is keeping stuff from entering the servers. So look, got to get past the CDN, got to get past the firewall, got to get past my seals, my alligators, my sharks, my lions and tigers and bears. Oh my. Then we got to get past the network ACL, and now we got to get past the security group just to touch the server, just to even hit my web server. But we are not done. This is still part of security. We got to do something to the server. Don't you think we should put another firewall on the server called the host-based firewall? I sure would. What about viruses on the server? We got to lock it down. We need some anti-malware protection. What else? If you type netstat on your computer, you're going to see your computer's listening on 1,000,001 services. This is a problem. So we have to disable unnecessary services. This is how you lock down systems. So we put firewalls, anti-malware, we disable unnecessary services. What else do? We patch our services. Now they've got to breach the content delivery network, our DDoS protection, our firewalls, our IDS IPS systems, our network ACLs, our security groups, our host-based firewalls, our anti-malware protection, and our hardened systems. That's not enough. Now we've got somebody knocking in the door. Now, the reason I'm going through all these stages is many people would tell you that IAM is security. We haven't even used IAM yet. Before we've gotten to IAM in our high security environment, you've had to beat the content delivery network, and you've had to beat the DDoS protection, and you've had to beat the firewalls, and you've had to beat the IDS IPS systems, and you beat the network ACLs, the security groups, the firewalls. Now you're knocking on the door of that server saying, I'm here, I went in. Now, how do you do that? Once somebody gets to your systems, you got to determine, who are they? Who are you? What are you allowed to do? And what have you done? What's that called? So, AAA authentication, identity and access management. In other words, we have to determine who you are, what you're allowed to do, and then track what you did. So with regards to IAM, we used to call it the simplest thing: authentication, who are you? Authorization, what are you allowed to do? And accounting, we tracked what you did. You know, we've come up with fancy word inflation, and because of the fancy word inflation, we've come up with some cool terms such as identity and access management. Understand, who are you? What can you do? Now, should we do anything else? What about the information that we've stored? Do you think maybe we need to secure and protect the information? Like, what if you break into the AWS data center and steal a hard drive? What else should we do to further lock down our systems? Well, maybe we should encrypt our data. So maybe, just maybe, we're going to encrypt our data. How are we going to do that? We're going to use AES 256-bit encryption. Now, mind you, everything we've talked about right now, which are the security technologies, we have not mentioned the name of an AWS service once. Now, I want you to know why. When you design an architecture, you're dealing with technology, not the names of the service. You're dealing with the technology. Okay, and I want to walk through this because I want you to understand this all. It's super, super important. And if you were to learn nothing from this, if you at least learn this from the architecture perspective, this would make the week completely worth it for you. So let's do this. A CDN, does it matter if it's AWS Cloudfront or it's Azure Content Delivery Network? It does not. It's just a name. And if it's Azure DDoS or if it's AWS Shield, it doesn't matter. You, the architect, are going to do the same. Now let's go to the load balancer. With AWS, a network load balancer is called an elastic load balancer. Guess what? If we go to Azure, it's called an Azure load balancer. Does it change? No, the functionality is the same. You as the architect, all the clouds are the same. So now let's go to the firewalls. We just went to the marketplace with AWS. You know where we get the same Palo Alto firewall on Azure? From the marketplace. Nothing's changed. So we need an IDS IPS system. Guess what? On AWS, we go to the marketplace. On Azure, we go to the marketplace. We're buying the same one. With the network ACL, whether you're doing an Azure ACL or whether you're doing a network ACL on AWS, it's the same functionality. Whether it's a security group on AWS or a network security group on Azure, it's the same thing. Host-based firewall, same thing. Anti-malware protection, same thing. Disable unnecessary service, same thing. Patch, same thing. Now, on the IAM side, when you're dealing with integrating with Active Directory with AWS, you use AD connector. When you use Azure, you use Azure AD. Again, no different. AES 256 encryption. Guess what? With Azure, it's done automatically. With AWS, you enable the key management system. It really doesn't matter, and that's what I wanted to impress with you. I wanted you to understand that it really doesn't matter which cloud provider you're actually using. But what really matters, what really, really, really matters is that you're using the right kind of technology. That is what makes the difference. It's using the right kind of technology that matters, that makes sense, as opposed to using the name of the service. And that's why we are so open to saying multi-cloud, learn the cloud, don't learn the vendor. Because when you do it this way and you learn it this way, you'll always know anywhere, anytime. So let's come out of this for a minute. Let's open it up to some questions that we're going to answer for a little while. We've hit some pretty complicated technologies, and I know a lot of people were really excited to get to mapping out the security environment. Now, after dealing with the security environment, where we talked about network security and 1,000,001 devices and appliances that not everybody may be familiar with, let's open it up and ask some questions. On what basis does guard duty aggregate logs? I'm not sure I understand the question. It's kind of one of these things that just sort of aggregates logs and follows an algorithm. So I don't know how to answer that. Yolanda, what is the difference between config and CloudTrail? CloudTrail is and that's a great question, Yolanda, is a very extensive auditing functionality for all services on AWS. And config is much more of a security version of it. Realistically speaking, CloudTrail, much bigger logging. So think of config as an additional security thing. You make a config change and it's going to verify it against the security policy, where CloudTrail is going to keep track of everything that occurred and by when. Aiden, what are some other AWS services that you can use to prevent DDoS other than CloudFront? Network ACLs, WAF, Shield, security groups, all those kind of things that you're going to use to prevent DDoS. The same things we just talked about, nothing changed. The only difference is instead of using a WAF, I chose a much stronger, more robust firewall, and I chose a much stronger IDS IPS system. All those systems are there. I've just chosen to use much stronger enterprise-grade devices. David, please. If you buy an enterprise-grade firewall in the marketplace, or they are actually EC2 instances. They're virtual machines with firewall software, and they are a single point of failure. So that's exactly why, David, you have to use 2 or more with an elastic load with a network load balancer. In fact, David Page, when you're dealing with advanced load balancer technologies and organizations need load balancers that are beyond the AWS capabilities, what they do is they create like these elastic load balancer sandwiches, and say they get F5 load balancers that are sitting on EC2 instances, which are really robust load balancers with an amazing feature set. And then they use the high availability AWS network load balancers to actually load balance the other load balancers. So a lot of what we're going to be doing on the cloud, David, is to actually work around some of the physical limitations of the cloud. Again, these cloud providers are smart. They're excellent at what they do. I don't want to make light of any of these services. They're unbelievable. And for the price, some of these WAF and Shield things are revolutionary. They're amazing. But when you're dealing with big organizations, you might need to deal with a company that's done nothing other than make firewalls for the last 20 years. Because the company that makes firewalls and nothing other than firewalls and IDS and IPS systems specializes in that. Where when you deal with AWS, they do everything. They do storage, they do compute, they do security. And when you do everything, you can't do any one thing as well as when you do only one thing. It goes back to the specialist versus the generalist. So 90% of the customers, the AWS Cloud Native things are going to be perfect. But the big ones, the ones that need more, are going to need those extra enterprise-grade features and functions. And it's not that the AWS services aren't amazing. They're amazing. Amazing. But if you've got an Olympian that does nothing other than Olympic gymnastics, that Olympic gymnast is going to be much better than a track and field athlete that plays football in the off season that does gymnastics in the springtime, because they're going to be doing a little of a lot of things. So that's why we're talking about going to the marketplace to get this really specialized, heavy duty, industrial grade component. So Chris, you want to bring in the next one? So, AWS would try and tell you that some of the things like the Shields and Macy kind of things, some of them could do some kind of IDS, kind of IPS functionality. For IDS, IPS services, either use a next generation firewall and don't worry about it, or get something from the marketplace. Ojo, what other firewalls apart from WAF and Shield? Well, there's lots of them. We got the basic freeware Linux ones like IP tables, which is what you get on the Red Hat variations, or UFW, which you get on the Debian distributions. Checkpoint has been in the firewall business. They're an Israeli company for probably over 20 years, maybe 30 years. Cisco's been in the firewall business for over 20 years. And who else? Palo Alto's got some great firewalls. Fortinet's got some great firewalls. SonicWall has some firewalls. I've never used them. They're not kind of in the world that I've ever been in. I've been in one of those big four players. Juniper Networks has some relatively good firewalls. So there's a lot of companies that make relatively good firewalls. Solo. Is getting a marketplace mean installing a third-party software? Well, the answer is yes. It's going to be an EC2 instance that's got the software. Now, the reality is, Solo, is when you go to the marketplace, it's pre-built. Basically, it's a machine image that's got everything installed. You just turn it on and then configure it. So the answer is yes. But if you had your own firewall software, there would be nothing to preclude you from basically just setting up some checkpoint firewalls and installing your own software. But in this case, you're buying it from the marketplace. That includes the license, it includes the systems and everything else. David, in my whiteboard example here, could you still use WAF in front of the CDN in addition to your marketplace firewalls for an extra layer of security? Could you? You could actually integrate an enterprise firewall and a WAF firewall. But having said that, David, the protection that you'd be getting from the AWS firewall compared to the next generation firewall wouldn't make sense. It's just not even close. They're good firewalls, the AWS firewalls, but we're talking these next generation firewalls. We're like legends and leagues and leagues apart. Epi, can I tell us about the aviatrix certification and its relevancy in the job market? Ipa, I'm actually liking the aviatrix multi-cloud network engineer professional. The aviatrix multi-cloud engineer associate, from the people that are telling me, they're telling me it's way too basic. Having said that, the aviatrix multi-cloud network engineer professional, I like it. I haven't taken it yet. I may actually choose to take it just to see what's on it. I just don't have the time to spend a weekend to study for a certification. I don't have a weekend. And that's typically what it takes to take one of these professional level certifications when you know what you're doing is dedicating a weekend. I'll probably dedicate a weekend to it in the next couple months if I can find a weekend to actually do it. I do think the aviatrix multi-cloud network engineer professional is a good certification, IPA, a really good certification, and I like it. I like that it is multi-cloud. I like it that it is vendor neutral, and I like that it covers networking. Since the cloud is nothing more than a network in a data center that's been virtualized, having strong network knowledge is good. A lot of Cisco people are at aviatrix, a lot of them. They've got a lot of network people, and there are a lot of good people that are building a massive brand there. And as it stands right now, aviatrix has not been plagued the way AWS exams have been plagued by exam dumps and cheating. AWS makes a great exam. But what happens, there's been so many people that have produced training materials that can get anybody to pass the AWS exams and still know literally zero about the technology. Because of that, the certifications have decreased in value dramatically. And aviatrix, because it's a newer exam, hasn't been hit yet with all the exam dumps and all the fake questions and all the certification courses that just teach the test and don't teach people how to do the job. So right now, I think there's some good relevancy on the aviatrix multi-cloud network engineer professional, not associate. So that's kind of my perspective on that right now, Ipraya. What is the difference between the functionality of the firewalls placed after the load balancer and the host-based firewall? This is some networking and security. The kind of firewalls we're talking about actually protect the entire enterprise. And these are big, robust firewalls. They block information coming in. A host-based firewall is what you have on your server or what you have on your computer, which basically says, if you breached everything else, protect my computer. So the host-based firewall doesn't protect your network. It doesn't protect your systems. It just protects a server. It's like when you're on a Windows computer and you turn on the Windows firewall. It's not securing your home. It's not securing your anything. It's just securing that one device to an extra degree. So traditional firewalls block everything. Host-based from coming into your environment, period. The host-based firewall protects just the host itself. Okay, where are we here? Now we're actually making some pretty good. Let me just see where we're at in here in the content to see. What we can probably do is we can talk a little bit about performance tuning And then I'll save some time tomorrow to actually talk about some architecture as well. But let's go back into before we do that. Okay, let's talk about tuning your network performance. Now, there's a couple ways you can tune your network performance, and there's all kinds of networking that we're talking about. But when we're talking with network performance in AWS, we're going to be talking about some things that are a little different. When we're talking about network performance, we've got a couple things that we need to talk about. And I'm going to spend a lot of time talking on these things because they're pretty important for your applications and your designs. The main things that you're going to deal with is if your network is no good, nothing will work. I'm going to say this again. If your network is no good, nothing will work because the network is the foundation. Do you know what 99% of the population never thinks of? The network. If the network doesn't work, nothing will work because it is the foundation that makes everything else possible. So when we're dealing with networking, we often can deal with a couple of problems. The problems are going to be related to one of the following areas. They're going to be related to latency. They're going to be related to variations in latency. They're going to be related to bandwidth. It's going to be related to packet loss. These are the kind of things that we're going to be dealing with, and I'll explain each and every one of them with you. So the first and foremost thing that we're talking about is routing. If you don't have a route to it, you can't reach it. Routing is fairly complicated. We have a lot of engineers and architects like me. We spent our lives studying routing protocols, which are algorithms. How do we tune routing protocols with the knowledge in our head of an algorithm? So when we did our BGP night the other night and I said, okay, we want to use this link and we changed the weight of that route to prioritize that link, that was us tuning an algorithm. And then when I said we want to use this link by raising the local preference, we tuned an algorithm. And then I said, let's reduce the multi-exit discriminator on this one to make it more preferred. We tuned an algorithm. So what we're dealing with to tune these things is we're going to change metrics to tune the algorithm. So when it comes to networking, it's all about your knowledge of the algorithms. So just kind of keep that in mind. Algorithmic knowledge, super, super, super critical. So let's talk about this. So latency, what is latency? We're all going to do a latency experiment right now. Latency is how long it's going to take you to go from point A to point B. That is your latency. Point A to point B. So everyone, right now, if you're on Windows, open a command prompt. If you're on Linux or a Mac, open a terminal. Right now, everybody, I'm going to wait until we all do it. We're going to have fun. We're going to do our first thing. We're going to find our latency to the Cisco website. Okay, so here's what we're going to do. Everybody, right now, I want to find out how long it takes for you to go to Cisco, and we're going to paste it in the chat box in terms of milliseconds. Right now, ping www.cisco.com. Hit enter, and we're going to send 4 ICMP messages if you're on a Windows system, and if you're on a Linux system. Now, everybody, I want you to look at it. Now, here's what I want to find out. First, I want to find out how long it took for you to send your message to Cisco and to get your message back. It took me 21 milliseconds. From my home to the Cisco page, it was 34 milliseconds for Curtis. I want to see it again. Okay, we'll do it again. Everybody, go to a command prompt or a terminal window. And this time, I want you to type ping -T, ping space -sign T, and then www.cisco.com. Note, we're all going to have different numbers. So I just want to see what your numbers are. This time, I'm at 20 milliseconds. Old Time Honey Official is at 30. David Page is at 30. EPA is at 22. Note, we all have different time to get there because we're all coming from different seconds. Derek Houston is 12 milliseconds. He's closer to the server. So that is the latency. So Derek is closer than I am. Curtis Page is 40 milliseconds. His latency is double mine. Now, I want you to think about that latency. 40 milliseconds for N. So 43 for Matthews. You can see we all have different times. Alex is close to it at 17 milliseconds. Alex is in the UK. He's probably really close to the Cloudfront or to the content delivery network. 46 milliseconds for Aiden. Hans, 610 milliseconds. See, we can see that the internet is not consistent. We've got as little as 7 milliseconds from Aqua and 6 milliseconds from Amrath to as much as 610 from Asim. See, we're all over the place over here, and that's the planet internet. So latency is something that we're going to contend with. Now, all of you, type ping minus T, www.cisco.com. And here's what we're going to look for. I want you to look at this. We're going to send a continuous ping, and I want you to look at it. If your line is good, and my line's good right now, I'm getting 20 milliseconds, 20 milliseconds, 21 milliseconds, 20 milliseconds, 20 milliseconds, 20, 20, 22, 20, 20, 20. I'm doing really great. Now, look at his seams. He's got 600 milliseconds. He's got 1,240 milliseconds. He's all over the place. Chris, bring up his last one. 1240. He had 610. See, what we're dealing with is that's called the variation in latency. That's called jitter. Look at Abdal's. Abdal's is the best. But when you have latency that goes from 4 milliseconds to 40 milliseconds back to 4 milliseconds, it's not good. And it's called jitter. Jitter is the variation of latency. If there's something that's going to kill your voice or video application, it is jitter. Jitter is as bad as it gets. And Asim, now he's at 278 milliseconds. So he's gone from 278 to 610 to 12 something, all in a thing. He's got a horrible connection. And that's what's going on. Now, he might actually have a good connection to other sites, just not Cisco. So this is what we're talking about. We've got to have, now he's at 9 milliseconds. He's all over the place. That's a line that's got a lot of jitter on it. So make sure that you're dealing with. So keep this in mind with regards to network performance. Latency, the less latency, the better the customer experience. The latency is half of your ping. You know why it's half of your ping? I send an ICMP echo to the Cisco website, and it goes through the internet, and it comes back to me. So that's why you have to divide by 2. It's the time that it takes to reach it and the time that it takes to come back. Now, is it possible that it takes me 15 milliseconds to reach it and 5 milliseconds to come back due to asymmetric routing? Sure. Again, that's jitter, which is why you've got to plan your routing, go out and back the same link. So these are the kind of things I just wanted you to pay attention to, because this is really critically important stuff. So there's that. So now, while we're at it, let's experience how we're going to route to Cisco. So we're not going to get the whole path. So everybody do this. Type TRACE. And if you are on a Windows machine, type TRACE RT. And if you're on a Linux machine or a Mac, type TRACE ROUTE. Windows machine, TRACE RT. And now type www.cisco.com. co.com. Now, we're not going to see every hop along the way, because once we pass firewalls, the firewalls will limit it. But just let's look at your path, at least part of the path for you to get there. Now, I want you to see that we're all going to have a different path. And our path is going to be determined by our internet service providers. So, for example, my first path is to my router. My next path is actually to my ISP. Right after that, I'm at SBC Global. Then, I hit a bunch of AT&T's routers. So I want you all to do it and see exactly how far away you are. Chances are you're going to be I'm 10 hops away from the Cisco website. Alex is 2. So the point is, it's going to be dependent upon your service provider. So while we're at it, if you guys are having fun with networking, type AWS Networking in the chat box. And that way I know you guys are awake, alert, and oriented. While you're at it, can you hit the like button, tell others to subscribe, comment, join our channel. We love working with people. We love sharing knowledge and information. So please reach out to us along the way. So let's go back to this. That way I know you're here. Love knowing that you guys are here because we work really hard to try and give you guys a great experience. And I want to know you guys are what do you call it? Are here and getting something out of it. Because it's not ask questions, we'll work with you. So now let's look about some variations in latency. I'm going to show you a healthy line, and then I'm going to show you some unhealthy lines. So right now, this is healthy. Well, this is when I last did it. I've got a healthy line here. This looks great. Look at this. Look at this. It's really, really, really consistent. This is what I want. Now, let's go here. I'm actually looking at my firewall because you can get a lot of information from your router and firewall. I've got a giggy connection to the internet. Look, I'm not using any of it. What am I using? On average, I'm using about 32 megabit per second of uplink traffic. And my latency is a consistent 8 or so milliseconds to what I'm checking. But I'm getting it from my firewall. Note, I'm not losing data or packet loss. So that's one of those other problems we're going to talk about. So what is... Well, let's talk a little bit more about jitter, and then we'll get to packet loss. So I had previously mentioned to you that jitter is really bad for real-time applications such as voice and video. And jitter is variations in latency. 1 millisecond, 10 milliseconds, 3 milliseconds, 20 milliseconds, just like Asim Hans's internet service provider. He's all over the place. Lots of jitter. So going back to this, jitter will be a nightmare for voice and video. So if you're watching video and it's coming from Netflix and it's always 5 milliseconds, no big deal. You turn on your Netflix, 5 milliseconds later, you're watching your TV show called You. I saw it the other day. It was pretty interesting. I'm watching it. Life's fun. Now, if packet 1 gets to me in 5 milliseconds, packet 2 gets to me in 500 milliseconds, but packets 3 through 20 gets there in 6 milliseconds, now I've got to auto-order data and I've got a problem. This is not good for video, or voice. But if it's just data, we can work around with it. But jitter. So here's what I did here. I took my Mac Pro, and instead of sending my Mac Pro out the Ethernet port, which goes through my fiber connection to the internet, I decided to basically use my iPhone over here as a Wi-Fi access point, and then have my Mac go through my Wi-Fi access point, just to see, because I know that wireless is not good for latency, and wireless is terrible for jitter. So here's what happened when I did it. Now look at this. Now I'm sourcing my information through, and I'm gonna my information, and it may not be the easiest thing to see in this window. Let me see if I can make it a little bigger. Hold on, how do I do this? Just to try and show this to you, make it a little easier for you to see. Now look at this. Here I'm sending a ping to Amazon, and I'm sending the same ping, but I'm sending it through a mobile network. ICMP message 1, 62 milliseconds. Next one, 59. Next one, 68. Next one, 47. Next one, 76. Next one, 92. Next one, 63, 68. This is not consistent. This is terrible. This is not the way you can't run critical applications on this. This is fine if I want to use my iPhone and I want to order a hamburger from Uber Eats. This is fine, but this does not work for real-time applications such as voice and video. This is not designed for this. So please keep that in mind. Note, if you look at the bottom over here, it's going to be hard to see. I actually have lost packet loss, which is data that's being lost. That's not good either. I don't want my data going away either. I want access to my data. So never good. So there's a difference between bandwidth and latency. So let's talk about the difference. Latency is how long it takes to go from point A to point B. So, like Aqua said, Aqua's got a great networking background. For voice, you want definitely less than 250 milliseconds round trip time. The less, the better. But you can tolerate up to that, assuming it's consistent. But what you can't tolerate is a lot of packet loss. So, latency is how long it takes. Now, bandwidth is throughput. So when we talk about hard drives and we talk about like storage, we talk about IOPS and we talk about throughput. And when we talk about storage and we talk about the number of input-output operations per second and say the more input and output operations you can do per second, the lower latency. And throughput is the number of megabits or gigabits per second that we're able to push. So that's with regards to hard drive. Kind of the same thing when it comes to networking. Latency is how long it takes to get somewhere. So someone, Marek, who's over in there in the Czech Republic somewhere, for him, it's 35 to 100 milliseconds to get somewhere because he's further away. But the point is the latency is how long. The throughput is how much stuff you can cram into the wire. So I like the race car example. We'll use the disk performance. IOPS is how far you can accelerate from 0 to 60. Latency is how fast you can accelerate from 0 to 60. If I can get to Aqua's house in 9 milliseconds, I got there fast. That is my latency. And latency and throughput are not the same. Throughput is like a tractor trailer. Throughput is the amount of stuff you can do. So let's say we've got a race car and a tractor trailer. The race car can go from 0 to 60 faster than the big giant truck that can haul 80,000 pounds. But the 80,000 pound truck that you can stick 2 metric tons or 5 metric tons of stuff in it, the stuff that you're carting is the throughput. So when we talk about networking and we talk about throughput, 1 gigabit a second, 10 gigabit a second, 100 gigabit a second, it's how much data we can move, which is different than the latency. The latency on a 1 gig line might be less than on a 100 gig line because it's how long it takes to go from point A to point B, where throughput is the amount of stuff you can push. So keep that in mind. The next challenge we have is something called packet loss. Packet loss is when you lose data. Remember, layer 3 electrons or bits, or layer 1 electrons or bits, layer 2 frames, layer 3 packets. So if you lose data at layer 3, it's called packet loss. Why would you lose data? Well, maybe your wire is bad, a layer 1 problem. Maybe your Ethernet card's bad, layer 2 problem. Maybe your routing's bad and you're losing data, layer 3 problem. I don't know. There's lots of reasons you can be losing losing packets. And it's going to take a highly qualified network engineer to know why and do the difference. And that's okay. You're going to get there. It's going to be a great day. So packet loss is a problem. Now, when you're dealing with real-time data, packet loss might not get there. But when you're dealing with reliable transport, packet loss will slow things down. And it can cause a massive problem with your links. So how many people here are familiar with the TCP sliding window? If you know the TCP sliding window, type in sliding window in the chat box. And if you don't know the TCP sliding window, let me know, and I will walk you through the TCP sliding window right now. Actually, you know what? I'm just going to walk you guys through the TCP sliding window. Something tells me that not enough people are going to know the sliding window, and I want to make it clear. So when we send data, Yaros, please refresh, never heard of it. Okay, we'll do the sliding window. So when you're dealing with sending data, you can send it either via TCP or UDP. And they work very different. I'll explain it to you. TCP, we're going to do it right now. Hey, everybody, listen to me as fast as you can. Listen to my data, see my data, see my data. I'm flooding it to you. I'm throwing it to you. I'm throwing it to you. I'm throwing it to you. If you heard what I said, great. If you didn't hear what I said, guess what? I have no idea. That's UDP or Uniform Datagram Protocol. It is non-reliable. I'm spewing out data as fast as I can, and either you catch it or you don't catch it. Where does that work? Right now, we're on YouTube. I'm spewing out 7,500 megabit per second video content. I'm streaming it over to the YouTube. Got a camera. It goes into a video encoder. It goes out my encoder to a service called StreamYard, which then gets streamed over to YouTube. I'm streaming stuff everywhere. If I lose some data on the way there, it's lost. There's no retransmission of the data. It's just lost. Lost, lost, lost. And it needs to be that way. I see Aquo's over there in England. I'm picking Aquo because he knows a lot of networking. He's really good with networking. He's a friend. So if I say, Aquo over there in England, come over for dinner today, and the words Aquo over there in England, come over for dinner today, arrive in order, Aquo knows what the message is. But if I were to retransmit lost data and the message was like, today, over, dinner, come, Aqua wouldn't even know what I was sending the message to him. So when we're dealing with real-time transport, if you lose data, keep it lost, because bringing things in fast enough aren't going to be good enough. You want it lost. If you're watching a movie and you miss 3 seconds of the movie, you can't rewatch the movie going back. It just keeps going. So UDP is designed for real-time data, streaming data, and that's how it works. Now, if we needed to be sure that our data would get there, we would use something called reliable transport. And reliable transport uses TCP, or the Transmission Control Protocol. That's what we're dealing with reliable things. So let's talk about how this works. I want to show you how this works. How do you do reliable transportation of your data? You have to make sure your data gets there. If you don't know if your data got there or not, there's nothing reliable about it. So let me try and delete this so I can show you this. Let's walk you through what actually happens when you're dealing with TCP, reliable transport of traffic. So here's what it's going to look like. And this is the way the TCP/IP protocol works. The TCP/IP works to basically make sure or guarantee that your data gets there. So what typically happens is I start out as the sender. I'm over here. Here's the way TCP works. I say, Aquo, I'm going to send you some information. So I open or synchronize a connection to Aquo. Then Aquo says, Mike, I acknowledge your desire to open a connection with me because you sent me a send message. I send an acknowledgement and ACK, and then Aquo says, guess what, Mike? I'd like to open a connection with you too. So he sends me a SYN. So the SYN opens the connection that I send to Aquo. Aquo sends an ACK, which basically says, got it, Mike, I agree. And he sends a SYN or a synchronize to open a connection with me. Now, Aquo and I now have an established TCP session between Aquo and I. Now, here's the way I guarantee that Aquo gets my message. I send Aquo one packet, and Aquo says, got it, Mike. And I send Aquo 2 packets, and Aquo says, got him, Mike. And I say, Aquo's got it, the network's good. Aquo, here's 4 packets. And Aquo says, got him, Mike. So I send Aquo 8 packets, and Aquo doesn't get the 8 packets, so he doesn't respond. So I say, uh-oh, I'm going to send Aquo a single packet. And Aquo's got it, Mike. And then I send Aquo 2 packets, and he says, got it, Mike. And then I send Aquo 4 packets, and he's like, I got it, Mike. And I send him 8 packets, and Aquo sends, I got him. I'm sending 8 packets, everything's going through. I go to send Aquo 16 packets. He doesn't acknowledge it, and I start back at 1. So I want you to think about this. Every time data gets lost on a TCP connection, instantly you start retransmitting at a slow pace. So what happens, the way TCP guarantees your data gets there, it's like robust military communication. You call the person, I want to make sure you're there. Roger that, I got it. You know they received the message. TCP acknowledges the message. And through these series of acknowledgements, that's how it's reliable. TCP does flow control. So I want you to think about this. Every time I tried to send my friend Aquo a message, he acknowledged it until he didn't, in which case I slowed down. So now think about this. Any noise on your line, any problems with that line that's going to cause you to lose data will have a massive impact on the performance of that line for TCP traffic because it's going to cause retransmissions. So now think about applications like wireless, which are not reliable. Just because wireless has a gig of throughput doesn't mean you're going to get more than 50 megs or 100 megs because of this retransmission thing. Because if you've got a collision or if you've got anything going on with your data where you lose one piece of data, everybody starts retransmitting. So understand when you're dealing with TCP/IP, you're dealing with reliable transport, which means flow control. So I wanted to make sure everybody understood that. Because these kind of systems are really, really, really important. And I wanted to make sure that everybody gets these things. Let me go back to where we're at right now. Okay, so bear with me one second. So we talked about packet loss. So next on the list is going to be as follows. I'm going to talk about placement groups for a few minutes, and then from there, I want to call it a day, and then we're going to have we'll open it up for some questions, and we'll have some lots and lots of fun for tomorrow. So let's talk about placement groups. There are times where you need to improve the performance of your environment. And what do I mean by performance of environment? Typically speaking, lowering the latency. So in the data center, we have a lot less latency because it's already in our systems. We're not necessarily virtualized. We're using storage that are on our systems, which is much faster than block storage. So they're kind of thinking on many of these things. So what AWS does, they give you the opportunity to put your systems closer to each other to reduce the latency of the communication between your systems. And this is really great. So think about it this way. If you've got a server and another server and they're separated by 1,000 miles, you've got milliseconds of latency. But if you put your server in the same rack, you have almost no latency. Or if you had a big server and you had multiple virtual machines in the same server, you wouldn't even have to leave the server for your data. So what AWS enables you to do is to create a very high performance environment where you can put your stuff really close to each other to enhance the performance. And these things are called placement groups. So if you ever have to build a high performance computing cluster where internode network performance is really important, this is where you're going to use a placement group. So the point is you're putting your stuff close to each other. So let's talk about the kind of placement groups. We'll begin with the clustered placement group. The clustered placement group is a very low latency group. Effectively, what's going on in the clustered placement group is you put your stuff all on the same rack. So, same rack. So think about the same rack. Single power supply, or typically a single power distribution unit. Typically think of a single network switch. So, really low latency. The speed of light, if you're not going more than 5 feet. When you're traveling 186,000 miles a second, the speed of light is really fast when you're only going this far. So huge speed performance. In many cases, all your systems are actually in the same physical server. So there's not even a switch, or it doesn't even have to leave the backplane of the server. So you get extremely good network performance. But everybody, look at this. What do we all think happens when we put all of our servers in a single rack or in a single physical device? We got an availability problem, everyone. Huge availability problem, everyone. We have a single point of failure. The rack. The power in the rack goes, everything goes. The switch in the rack goes, everything goes. If you're all on the same server and the server crashes, everything goes. So, clustered placement group. Lots of performance. Unbelievable performance. Low latency. No redundancy. Dangerous, dangerous, dangerous. So, if you're going to make a clustered placement group, make 2 of them. 1 is none, 2 is 1, and 3 is greater than 2. If you're going to make a clustered placement group, because you have the need, and I've had to create lots of these in my careers, have a backup. 1 is none, 2 is 1, and 3 is greater than 2. So that's the clustered placement group for maximum performance. Now, what if by comparison, you wanted something that was a little better from a redundancy perspective, but you still want a good performance? This is where we talk about a partition placement group. And in this particular case, we spread our virtual machines or compute instances across racks. So they're in the same data center, but they're spread across racks. So now if you've got a power failure in a rack or a switch failure, you're still up. So now because your systems are still close to each other in the same data center, your performance is still very good. Less performance than the clustered placement group, but still very good with much lower single points of failure. So strongly, strongly, strongly recommend this. This is your option. Now, if you want to see what this looks like, I can show you. It's going to look like a partition placement group where you can see your servers are spread across multiple racks. And by doing so, they're all in the same data center or availability zone, but they're spread across racks. So we really, really, really eliminated single points of failure. Now let's go to the next concept, which is the spread placement group, which is the safest way to do this. And this is where you spread your instances across more hardware. So in a spread placement group, you're across racks, servers, PDUs, power distribution units. You're going to be grouping your systems across multiple availability zones. So this is obviously going to increase your latency, but it's going to give you a lot more availability. So this is a trade performance for availability. Still, their instances are close, but it's less close than the previous environment. And by doing that, much more availability, much big reduction in single points of failure. But just keep it in mind, you're trading some of the performance. So let's look and see what it looks like. In this particular environment, here's what we've got. We've got 2 AZs or availability zones. Our equipment spread across 5 racks. We still have high performance, but now we have high availability. So these are the levers. The closer your stuff is, the greater the performance to each other. The further your stuff is from each other, the lower the performance, but the more distributed it is. The more distributed it is, the less single points of failure you have. The less single points of failure you have, the more likely your systems are to work. So just keep all these kind of things in mind. So all kinds of stuff is good. I just want to make sure that you're pretty familiar with which ones. So let's do there. So at this point, Chris, because we're getting close to 3 o'clock and we're really, really, really good on time for finishing tomorrow and having a really good day with it. I want to make sure we ask some questions. I also want to say that unless anything changes, at 5 p.m. tonight, we're going to have a lab party, a technical party, unless anything changes tonight with Imran for the cloud engineers and the people that really want to know the cloud engineering. We're going to have lots of cloud engineering. So we'll do lots of some of these things. For those people that want to actually see how to configure these things, they will have the opportunity tonight at 5 p.m. Eastern, unless something goes wrong. And if it does, I will find another time to bring on Imran to do it with you. But we are still planning on going until we hear anything else otherwise. So when it comes to redundancy, the more you've got is better. 4 is greater than 3, 5 is greater than 4, and 6 is greater than 5. When it comes to high availability, when it comes to performance, the better prepared you are, the better you'll do. So, Chris, if there's any questions, I'll do my best to answer the questions before the end of the day.
Don't have any questions currently, so just waiting for. I'll wait for him to come in.
For real?
Yep.
I was that good about answering them and keeping caught up?
Well, they didn't really ask any while you were doing stuff.
Okay.
Here you go.
So for best performance with high availability, you could configure 2 custom placement groups in the same availability zone next to each other. By doing that, you would really improve the performance. Although you could also do them across 2 availability zones, but you wouldn't be using a load balancer to load balance between the placement groups. You would just have 2 redundant groups that are up and running, all in that way to try and make sure we've got it. So I hope I answered your question there, David. We're not going to use a load balancer to load balance between the placement groups. We're actually just going to have 2 separate unique ones. Asim, in TCP, how do we know the receiver has received all and not only some of the packets? They send an acknowledgement. Every time they receive the right number of packets, they send an acknowledgement. It goes through that sliding window. I send 1, they acknowledge them. I send 2, they acknowledge them. Now, when we send these messages, they all have a sequence number, so we can actually see which messages were sent and which ones were received. So we'll receive an acknowledgement. And same, if you have a Linux system, if you want to do like a sudo TCP dump -I, and you mentioned, and you actually look at the Ethernet interface or whichever interface that you have, or if you were to download a protocol analyzer, Ethereal was one of them. There's lots of protocol analyzers and sniffers. Cisco's got a free one that's out there. If you run a protocol analyzer, you actually look at what's going on, you'll literally be able to see the sequence numbers, the messages, the sends, and the acknowledgements. So you're going to actually get an acknowledgement, which is going to have a number that you can physically see to see that the message has been acknowledged and sent and received. Any others? For real? Any others? We may have just explained everything so well that there's no questions, but given my experience, people have questions and we love answering questions. So, if there's some questions, we're happy to talk about them. And if not, we'll finish up early and we'll come back at 5 o'clock and we'll get hands-on technical. Yeah, that is kind of cool. AWS, that is kind of neat. So, okay, examples of things that use UDP. Okay, things that use UDP are voice, video, the protocol TFTP. Anything that needs to be in real-time tech with Mufaz is always using UDP for transportation. Things that need to be reliable, such as FTP or HTTP or SMTP for mail, is always with UDP. So anytime, it's not going to be a service that's going to use it, it's going to be an application. All real-time data. So when you do a voice over IP phone call, it's UDP. When you do screen sharing and you're doing a screen sharing, typically, and you're sharing your screen, it's UDP. When you're watching YouTube, you're watching UDP. If you're watching Netflix, it's UDP. So real-time data, UDP. Data that needs to be reliable is going to be sent via TCP. And Wireshark is the freeware tool that, what do you call it? And Wireshark is the free Cisco sniffer that everybody else is using. Okay. Any last questions? If not, we'll come back at 5 p.m. And truthfully, it was really wonderful being able to spend some time with you guys today. We've got lots more to go tomorrow to finish our last day. We should be able to finish up tomorrow so we don't have to go into the weekend, though we reserved it just in case, but we're making really great progress. I hope you guys had a wonderful, wonderful day today. I know I had fun. If you guys are enjoying yourselves, if you can let me know by typing #CloudHired, and we will be back at 5 p.m. unless anything changes. But I'm going to wait one more second just to make sure there is no other questions. So what's a good day? The session tonight is going to be free as well. Tech with Mufaz, you learned a lot. That's wonderful. David Page, fantastic. Thank us both. It is going to, today's session, Asim, is going to be configuration. So I'd like everybody to attend, but hands-on configuration are things that engineers do where we architects don't do it. But all of us architects should know how. So we should have seen it before. So should know how. So what'll happen is at 5 p.m., come back on our channel and you will see it, assuming we're here, which is 95+%. So thank you so much. It's been a real honor to speak with you all, and I will see you all in a little bit. Everybody get cloud hired.